globe paradigm and
No, I mean,
externally to the not globe paradigm, right?
yeah. So internally, I
Okay, so
mean
then if you're
geometrically and
saying that it's
mathematically consistent, right?
internally, hang on one sec, before, I don't want you to go too far. Uh, you're saying that it's internally and externally consistent, therefore it's not exclusive. You're saying
Yeah.
it would be acceptable on both, and it's not like exclusive to a sphere. So you're agreeing with
So,
basically everything that Witsit was saying.
so mathematically, it's consistent internally, right? We have a Cartesian coordinate system solving for relative positions in that Cartesian coordinate system. There's no bearing on the shape of the Earth there. And sorry, I'm making a copy. Hope it's not noisy. So we have this provably internally and externally consistent mathematical framework matches reality as measurement, right? Which you can infer from that the satellites are actually where they say they are. And then from that, you can determine the properties of the surface of the Earth because you have this coordinate system that is consistent mathematically and consistent physically.
I think you're using equivocal predication on the term externally, where
By
externally
externally, I mean
how
that it
can
matches
something
reality,
be
right?
internally and externally consistent?
So the maybe I'm misusing the terms, but what I'm trying to say is that the internal mathematical model, which is a simple geometrical model, is internally self-consistent. It matches reality, so its external view is also demonstrably consistent. In that the mathematical model will produce values in reality,
So
specific
internally
distances between.
consistent would mean that when we plug in values, assuming a given thing, we get results to that given thing, right? Externally consistent or not internally consistent is saying that it's not exclusive to that one given thing.
So maybe I'm using
Yeah,
the
so
wrong term.
the correct term you would want to use there, Dazza, is not mathematically consistent. It's mathematically equivalent.
But wait, how do the receivers determine the time? Because it's determining the location of the satellite, they need the time, right?
Yeah, so it's a solution to simultaneous equations. So if you've got four variables and four equations, which means four observations, you can solve for all four variables. And in the case of GPS, time is one of the variables. So if you've got four satellites, you can determine X, Y, Z, and the time bias, or whatever it's called.
Yeah. So then you agree, though, that if there's some type of assumption baked into the receiver and how it calculates the time, then of course they would all agree. And
Not an assumption. It's a simple. So the equation is a simple geometric equation, right? The length of the hypotenuse of a triangle is squared equals the sum of the squares of the other two sides. You know that relationship?
Say it again.
A squared plus b. So on a triangle, a squared plus b squared equals c squared, right? So that works in 3D as well. And essentially, you're solving those hypotenuse distances for X, Y, and Z. So you know all of the distances with a time uncertainty, and you have to mathematically solve it so that you can work out what time is. And that's the other consequence, is that you and another receiver nearby will both that receive the same observations will also agree on the time difference of arrival of all of those signals as well after you've done the solution.
Well,
So you can't.
okay, go ahead.
No, you go. Sorry.
Well, so I mean, I'm saying you keep saying like if they agree, but that's what that doesn't mean anything to me, because if there's an assumption baked in at all, then of course they would agree, right? So you're just claiming that there's not an assumption. You're claiming that they solve a squared plus b squared equals c squared, and then they determine the time.
Yeah, plus time, right? So there's a time is another variable in that equation, effectively. And a squared, b squared, c squared is a simplification, but it's the geometric distance between 2 points in space is essentially the same as finding the one edge of a triangle, right? But you've got x, y, and z instead of just two sides. It's the same. It's squares and square roots, right? A square root of a sum of squares. But you have an uncertainty in the distance because you don't know the time.
Exactly. So
time
you're
is
like,
another
it's
variable.
circular. It's circular.
No. So it's simple maths. If you have one more variable and one more equation that involves that variable, or one more observation, so another instance of that equation, then you're able to solve for all four variables. And if you've got more, so there are other errors as well, if you've got more observations, more satellites, you can actually then start to solve for other unknowns in the system as well. So, and that's the internal mathematical consistency that I'm talking about. And those end locations are also consistent with each other externally as well.
And because those receivers are bound by the physics of their physical separation and the propagation of the signal, the speed of the propagation of the signal, there is no way to somehow bake it in so that they
Wrong.
can agree but not agree.
Wrong. That's totally wrong. You just made that up. Why did you say that as though it was so true,
No.
with so much conviction?
That was going back to the thing. Were you here when I was talking about the cannon?
The cannon, we're not talking about cannons. We're talking about a receiver that's supposedly receiving a signal from a satellite and able to accurately determine the speed and time of a signal, thus determine its location, thus its distance, and then we're going to take that distance and we're going to compare it to like four other locations doing the same thing, map it out on a globe and say this only works on the globe, it wouldn't work on the flat earth. So in order to even begin to build that argument, you're going to need to actually be able to stamp the validity of the initial time deduction. Just claiming it's impossible to fake it doesn't make that true at all. It doesn't even have to be faked. It's baked in.
So Witsit, if you receive a radio signal and somebody next to you also receives that radio signal, what are the variables that determine the time difference in receiving those two signals?
Receiving them from where?
From anywhere. So you're both listening to a radio signal. You know it's the same one because you're recording it and you look back later. But you can determine that the time of arrival is different.
It would be based on the distance, but the problem is the problem is though we have little satellite receivers, and you're trying to compare that to like a ham radio. It's not the same thing at all.
No. It's exactly the same. It's a radio propagation, and it's designed explicitly to time sync. And then Shubil was talking about this in great detail before, that you basically lock onto the carrier phase and you're counting how many wavelengths between you and the satellite. So you know to very high detail what the time of arrival of the signal is at your receiver. And you can actually, and this is what RTK is that Finky was talking about. It's basically transmitting the phase difference or the error in phase effectively, so that the other receiver can say, that the atmosphere is causing the phases to shift a little bit. I can apply that and get a much more precise relative location. And if you fake the location, if the signal's not coming where it says, one receiver won't be able to tell, provided all of the other signals are faked in the same way, so that it gets a consistent view. But the second receiver, it will immediately start to show the fact that the signal is not coming where it claims, because the expected time difference between one receiver and the next is not the same. So you can spoof the signal for one person, but to spoof it over a large area means a custom signal for every single receiver.
Sorry, I was just saying I'm switching my. Okay, you can hear me?
Yep.
Okay, so like, okay, we agree that in order to make your guys' argument, then you have to be able to verify that the time, like the duration of the signal that the receiver's claiming is accurate.
Consistent, internally consistent.
Yeah, you need
No
to know
accurate.
the
No
actual.
accurate.
Yeah. So you need to
Needs
understand
to be
what the
accurate.
time is very accurately. Yes.
Yeah, because that's what's going to give us our distance, and then we're going to take that distance. We're going to compare it to like other locations on the Earth, and say now we know all those distances, and when we compare them all, it can't work on a flat Earth. Those flat Earth distances would be different.
Yeah. So well, just even ignoring the shape of the Earth for a minute, that if you know the physical distance between two receivers, okay, you've measured it precisely with whatever mechanism, laser ranging or whatever, and you know precisely how far the receivers are apart, then the time of arrival of the signal of those two receivers compared to where the satellite claims it is must also line up, right? So if the signal is not coming from where it claims, then it will arrive at two receivers at unexpected times.
But dude, the
And that
times
will
are so inconsequential, right? We're talking about
no.
microsec.
So yeah, nanoseconds, right? We're measuring our time to nanosecond precision.
Yeah.
Yep. And you can do this, and Shoebill's got the gear that does this. So the between multiple receivers, you can also solve the equation with that nanosecond precision. So down to very high levels. So you can get very precise locations, and if you separate those receivers by a larger distance, you will find that it gets harder and harder and harder to fake the signal and keep the timing consistent.
Yeah, but like so I don't remember all the specific names of this part of it specifically for sure, but like from understanding, you guys claim this that like it's like perfectly in phase and it knows the exact time, but that's not actually what works. Like there's an ambiguity that exists, and there's like
Oh, yeah.
an algorithm that it uses to basically resolve it, and it's like it guesses basically.
Yep. It's an iterative process to work out what the actual phase you're on, and it uses a number of things. But same deal, until you get the number right, your position is all over the shop, right? So you solve the equations given a given phase. If it's not right, you're out of whack completely. And it's not until you get your phase right that you get this consistent, repeatable, reliable measurement. So GPS can
Well, like, but like
tell internally whether or not its data is consistent or not, right?
well, but this is the thing, right? Like it's gonna have to. From my understanding, it literally uses the globe model, like the globe grid, to determine um like what exactly, like how many like little like waves should be between the receiver and the satellite.
It doesn't
And
use the globe grid. It uses the ECEF coordinates.
okay, it uses ECF, which is based on WGS84, and I think it also uses um the ephemeris data. So it's like it bakes the it bakes the globe in, bro, and then it determines what it should be. It looks at the time, and then the ambiguity between the time, the little wave packets or whatever you want to call it. There's a corrective factor applied to it based on how many waves should be between here and the satellite, right? And it interprets this as like a correction factor, like removing error. But
Yeah,
of course, as
well,
it
but
applies to what we're doing, it's that removal of error amounts to affirming the consequent.
no. So the phase locking and phase counting, um, it is not an arbitrary thing, right? That so when you solve your position in GPS, you get like a residual error that tells you whether or not you've got good data. And when the phase ambiguity is bad, and you're not on the right cycle, your errors are huge, right? And it's only when you actually get a on the right phase, that your solution ambiguity goes right down and the residual becomes very small. And that's how you know that you've got the right phase information, because if you have any other one, you cannot solve the location properly. And it sounds circular, but there's strong mathematical proofs behind it, and they've got some really good techniques for rapidly determining the correct phase.
Well, bro, I think this is
And,
where you're about to
and
find out that this is all about to collapse in on itself, right? Like it is circular and it does use, like, from my understanding, it's like highly complex math. So like it actually uses like linearization for like locally.
yeah,
Yeah, because like the math
it's
is so complex if you don't do that. I'm not saying that proves the Earth's flat or anything like that. I'm just saying like ironically that's what it uses. But if it doesn't have like the globe baseline, like if it doesn't have
you don't
the
need the
algorithm with
surface
the
baseline. You don't need the surface. You just need the center of mass.
okay, but you have the globe baseline, that's what that is, built into the algorithm, and then it starts to like correct for it, right? It solves the ambiguity. It has to pick the right like phase. It's literally
Okay.
a software that's built into the receiver that's trying to determine what the proper phase is. Now, listen to what Jake was just saying. It just sits there and it just, as soon as it gets there, it knows it's in phase and all that stuff. That's not what happens at all, right? There's a software built into the receiver and it determines the right phase. And it does this using an algorithm that has the ECF built into it. So it's like, bro, where every corner I turn around, I need to know the globe to prove it's the globe.
So
Now, I don't know.
let,
I don't know what it actually. I don't know what it actually was. You guys are believing that it's like what it actually receives. The like is like the proper distance of the globe or whatever. But what we know is that like there's a huge spectrum of phases, and it uses this corrective algorithm to determine the proper phase that it's supposed to be.
so the phase ranging is only the final drop in the ocean, right? We can, and GPS used to work purely on the course acquisition code timing. So which it gives you like a 5 or 10 meter error, but you don't need phase to solve your position initially. Phase is a refinement. So even ignoring the phase ambiguity problem, we can actually apply the same consistency test that we had before and show that multiple receivers of known distances apart must all be able to simultaneously solve the entire solution of equations. So they need to be able to simultaneously solve for time, distance, position of satellites, and position of each other consistently for the solution system to actually function. And they can do that. Then if you can go to the
And the
carried
most
phase,
I think the thing that we need to really emphasize, though, is because it's based on the physics of propagation of light. There's no possible way to somehow make them think that they're not where they are, so that they're actually on a flat plane when they're really wrapped around a spherical Earth.
Yeah, there is.
To still, no, you're not going to be able to
Yes.
show that mathematically. And
show
Yeah.
us,
Yeah, you
show
can.
us, show us,
I just
Witsit,
did.
show us
I
the
just showed you.
mathematical.
There's a phase. The even get the
No,
phases. You're
you
yes.
don't need
Of
phase
like first of
information
all,
to
there's
do
a
this.
linearization. There's a linearization locally. Right. That's what happens. And then there's a software built into the receiver. And this off the top of my head, I don't remember all the names and stuff like this. But I know
Linearization
that
is just a mathematical process, right?
yes. Okay, but my point is that
Yeah,
there's all kinds
it's
of
a model.
math built into the software in the receiver that's going on to determine the distance. That's what's happening. It's
Yeah,
not just receiving a
but
signal and knowing where it's at. That doesn't happen. That's not reality. That is not what happens at all in reality.
the maths is known. You can do it yourself. It's publicly visible. You can actually build your own receiver if you want to. The and the other thing is, yeah, regardless of anything you may believe about how the data is manipulated, the propagation time must be consistent between multiple receivers, which means the position of the satellite must be where it says it is. Otherwise,
Why?
none of the satellites will agree on the positions relative to each other, and none of the receivers
That's
will agree on the relative positions.
No, what? No, that's not true because the receivers already have the algorithm built into it. So guess what? You guys
No,
you
they
guys
don't.
don't get it.
How does my receiver know where the one up the street is? It can only
No, it's
solve its
just
position
no,
based
it's
on
the
the data, right?
satellite. The satellite's taking care of all that, bro. The satellite
No,
is
it
sending the.
send the same
Yes, it
signal to
is.
me as it did to the guy up the street. Everybody
Okay, but
gets the
what's in that
same signal.
signal? What's in that signal?
Essentially, it's just time and the ephemeris.
That's right. That's right.
Yep.
It's got the
So,
time based on the ephemeris.
yep.
So the
So,
okay.
so if we
Uh-huh.
both work out the time, each receiver works out the time, and they use that they plug that into the ephemeris to work out where the satellite is. Then they work out the time of flight for the signal. So each is calculated its own time of flight. Then we can say, right, what was your time of flight? What was my time of flight? What's the difference? That's the difference between us and the satellite distance-wise. And that has to be consistent, and it is. So it's basically turning your GPS trilateration into a cross-receiver time difference of arrival, like Lorraine. So each receiver gets a very consistent view of the difference in time of arrival of the same signal, which means the whole solution is geometrically as it's claimed.
So again, it all boils down to you claiming the validity and how dependable the signal the receiver receives is, like how accurate it is. But you agree that if there is a process that takes it and corrects it, it would refute your points.
Corrects it when?
No, you're still not getting it. Witsit.
I'm not getting it.
You could have three receivers, right? Because of the altitude of a GPS satellite, you could potentially have three receivers, and the furthest apart could be like 10,000 miles between them, and they're using a signal that's sent at the same moment in time from each satellite. That all the three receivers that are spaced across the globe, that part of the globe of the hemisphere, they're all looking at the same satellites to do this calculation. And it's based on the physics of propagation of that signal at the speed of light. And it's the same identical signal. There's no possible way that they can lie about the location of those receivers in reference to one another and still have the solution be mathematically solvable. That's what Dazza is trying to tell you. And you're claiming that it is, but I know that if we push you to show us the math on how that's possible, there's no way in hell you'd be able to show us how you could mathematically have them separated by thousands of miles that are based on the timing of a pulse, of a signal of light, the timing of that light, and have them have a logically consistent answer amongst them, a solution, a location solution.
Just a second, dog just came up here. Hey, go back downstairs. Just a second. Okay, I'm back. Okay. Last thing I remember you saying is that you're saying it, but I guarantee you couldn't show that the math works or whatever. Is that really what we've gotten down to, bro? Like,
That's
I
not the
fully
last thing you were
understand.
saying.
That is the last thing you said. That's literally the last thing you said. You want to bet money on it?
I think you should keep your money for yourself. You have more need than I
I
do.
think you should not come off of
And
mute and say
you should
things
be
that are
not so
just
quick to
stupid.
always bet money on everything all the time.
Well,
Like,
then you should not be so quick
anyways,
to jump off the mic and
can
just
someone
make stuff
repeat the
up.
last point?
Anyways,
'Cause
anyways,
it was
anyways,
true.
anyways, anyways. Is that what we're doing? We'll just say anyways through people and just act like we can big bro them because we're on the internet and just disrespect them and just
cut off what they're saying and say, anyways, like it's just
A
irrelevant.
coward keeps running their mouth when the other person respectfully yields. Yo, someone bring up the point again. Let's put this arrogant fool in his place. Bring up the point again.
Anyways. You see how ridiculous it is to do that to somebody?
It is what it is.
I mean, it's just
So the
like,
challenge
bro,
is-
you said nothing of any substance specificity
let's hear
at
your
all.
the rebuttal from the other
Can you
side.
even
and
still? Hey, come out. Hey, big guy. Can you still man their argument?
Witsit, you're muted on my end. I'm curious to hear what.
Hey,
the
can
other
you
person
still
has to
man?
say
Can you still man their
before
argument?
you
Okay, then
ran
you're
away.
muted. Then you're muted. Then you're muted. So, oh my goodness. Okay, so anyway, the point is, right? You're saying that it's impossible to correct for it. It's impossible that they bake it in because it's just based on the propagation of light. You just keep saying that phrase as if that somehow is like this wind or something. You have multiple people, so they're separated by thousands of miles. The different receivers, you're saying you can't determine the distance, the relative relationship between the receivers, the distance between the receivers in relation to the satellite using the same signal because it wouldn't mathematically work. Like, what? That doesn't even, I don't even
that's
understand how that's
true.
rebutting what I said.
Yeah,
It's not rebutting what I
so
said, though.
it is. So to solve for the GPS position, ignoring phase ambiguity, just using the course acquisition code, to solve for your position, to solve for multiple other receiver positions, and have everybody agree on each other's position based on measuring the position between them, there's no mathematical solution purely based on the time of arrival of those signals that you can come up with that will solve the problem, because they all get the same signals. You can prove that. You can record the signal and see that they all got exactly the same signal. The time of arrival was different. That is all. And it's not mathematically possible to come up with a geometric solution that solves both the real distances between receivers and the actual time of arrival without the satellites being where they claim.
Okay, so I think I followed all that. So, okay, so for one, like how are we determining the distances between the receivers on the ground?
Any means you like, any high precision measurement you like. So they don't have to be thousands of k's away, like Jake said, although you can demonstrate it in principle thousands of kilometres away. They only have to be, depending on what technique you're using, they only have to be hundreds of meters or a mile away, right? You can measure that with a laser ranger or something like that. So you know the line of sight distance between all of the receivers.
Wait, we can do what to determine it?
You could use a laser ranger or something like that. You physically measure the
You're saying
distance
like
between
super
them.
close range receivers?
No. They don't. They have to be separated by some physical distance, right? So you have your receivers spread out over the countryside. They may be 500 meters apart or something like that. And sorry, I've just moved from Wi-Fi to mobile, so I'm probably dropping out. So you have these receivers at measured relative positions. You don't care where they are absolutely. You just need to know the distance between all of the receivers accurately, which you can do, right? That's a well understood problem. We know how to measure distances between things on the ground very precisely, especially over short distances like that. Then you just simply record all of the satellite signals over a period of time, take them away, and play them back, and determine if the whole thing is consistent. So whether at any given point in time the satellite ephemeris matches the time of arrival of the signal to all the receivers based on the known distances, whether GPS coordinates that each satellite would calculate also corresponds to the distances. So you have all these consistency checks that you can do to make sure that the satellite is where it says it is, the signal same across multiple receivers, and that results in a consistent view of reality between each individual receiver.
Okay, so let's just make sure everyone's on the same page here, right? Because, and I'm almost positive you're good faith and all that, but it's just the way that it's framed. It's just not. It lacks specificity. It's always set. Just so everyone understand, the signal, the time we receive the signal, the distinction between something as small as 500 meters, we're talking mind-blowingly close to each other.
Yeah.
Okay,
It's very small, but your GPS
Well,
receiver.
wait.
Sorry, yeah.
Go ahead. You go ahead. The GPS receiver, what?
Yeah, so your GPS receiver is already resolving time down to a nanosecond level, right?
Well,
just to solve the position.
Okay, but this is kind of where we're going to get into the territory of what I'm explaining, right? We were initially trying to say, and the reason that like I followed you all along was this idea that I didn't need to know the exact time. But you do, and this is why it's circular, because you're invoking distances in time and depending upon them and then claiming that they're exclusive. It's just circular, right? So like for one, to actually like resolve for the time, they use Sagnac effect and relativistic clock corrections.
We can leave everything out relativistically, and we can ignore. Yeah, we don't. Most satellite commercial, like consumer grade receivers, don't rely on any relativistic effects. They do all include a fact that the Earth is rotating effect, but we can ignore that. We can just simply solve for position without applying these effects, right? And we will still be able to solve across the whole network of receivers and across all of the satellites that are observed during the time period. We will be able to solve consistently for position and time and have consistent point-to-point positions on the ground, even without those relativistic corrections and even without applying Sagnac. There might be some absolute errors there, but the relative positions will be rock solid.
Okay, I don't know what you mean by you can leave them out, right? Like they're like baked into satellite data, but like even if we set that aside,
they're not baked in. They're not baked. The receiver does
they are.
not.
A university literally went and looked at it, and what was claimed to be raw data already had Sagnac and relativistic corrections applied to it. So I don't know how you could ever make that claim.
So we don't really care about what's baked into the signal. All we care about is when the signal arrives.
Sure, but the receiver is determining when it arrives based on the information in the signal.
Just on the time information, and we can use the ephemeris, yes. So we need to know where it is.
Time information is tied to the relativistic corrections, bro. That's what it is.
So the time, there's relativistic corrections to the clock itself, right? So the clock ticks at a different rate. But regardless, right, of what corrections happen before the signal is transmitted, they all get the same signal at the same time, at different times.
First of all, it wouldn't be at the same time. Yeah, but this is what I want to point something out. It isn't inconsequential. I'm willing to set it aside because I have a couple other points that I want to talk about, but like it isn't inconsequential by any stretch. It isn't applied the way that you think it is. It isn't applied in the clock mechanisms itself. It's applied after the fact. After the clock gets the reading, there are post-reading corrections applied to the data. This was proven by a university, not flat earthers, not geocentrists, nothing like that. Just an independent research team at a university that wanted to go and examine the satellite data, and what they discovered was that there were Sagnac and relativistic corrections applied after the fact, after the readings were taken, and then it was presented as raw data.
Okay. So we're dealing with the data straight off the satellite here, right?
Well, the data is it cooks the books. That's the point. But like it's fine. It's fine.
We don't care whether
we're
trying to show. We're going to show whether or not it can be cooked, right? That's the whole premise of this.
No, Ron Hatch wrote an entire book explaining how he helped them cook it. The satellites cooked the
Ron
books.
Hatch developed a Hatch filter, which is part of the phase thing, but he didn't fundamentally change the way GPS operates. But in any case, It's almost
No, but we're
irrelevant
talking about the
as to
time.
whether
We're
or
only
not
talking
they.
about clock synchronization. We're talking about relativistic clock correction. We're talking about the synchronization shifts, right? Because obviously the satellite altitude and the clock synchronization shifts, right? Those are like interchangeable mathematically. Those are not. You can't have one without the other. They are conjugates mathematically. Like they are tied at the hip. We can't just flippantly toss out clock synchronization specifics and act like, well, now we can know for sure they came at different times. That isn't how it works. And satellite's the biggest rabbit hole of all rabbit holes, and Ron Hatch wrote an entire book about it, and he explained it is not what they are telling you it is. And it does not work with relativity. And it has to have some type of etheric corrections. And he literally was hired to do it and had to do it. And that's actually what goes into the phase corrections that he implemented, and
Yeah.
he writes about it extensively. And then his book was taken off of publication. You can't find it anywhere, blah, blah, blah. But
So,
set all that aside. Good.
it doesn't matter what is in the transmitted signal. You cannot cook the time of arrival for different receivers.
Why not?
And if the time of arrival is not, why not?
Yeah.
Because there's only one signal.
There's only one signal. Yeah, we're talking about okay, but the signal interacts with the software that's programmed into the receiver.
No. You're missing the point entirely. You can grab the signal before the receiver touches it, just the radio component. You can capture the GPS raw signal. You do the correlation filter, you hook onto the signal, and you actually capture the raw signal before it is processed by the receiver. And
Wait, how are you
all this
determining
from,
that it's the same signal that way?
Yeah, that's exactly. So you record the raw signal and play it back later. So, but you're recording it simultaneously from a bunch of satellites, right? So you don't need to know the exact time at the time you record it. You can just record it and do like little snapshots of the signal from all the satellites you can see at a point in time. Then after the event, you can process those raw signals and turn it back into locations. The data your guys got sounds like that you talk about in this paper. I've been trying to. There's only like a one-line thing saying that it had these corrections. They don't really tell us where it came from. I think it's ground station data that they were getting from multiple satellites, and they were expecting it to be unprocessed, and it sounds like it was processed. But same deal. It doesn't matter that if the time of arrival of the signal can be determined, or the relative time of arrival as well, between multiple receivers can be determined without knowing what is in the actual signal. That so the signal's got a particular pattern. You can work out just from the pattern of the signal, without knowing what the contents mean, when the signal arrived at receiver A and when it arrived at receiver B. So you can tell that there was a time difference. But if you know what's in the signal, we can do better.
Here's what I want to know, right? Like, how does the receiver translate the code into a distance?
So it is using the ephemeris, so it knows where the satellite was and when the signal was transmitted and when it arrived.
And,
so you know where and when
that's
it came
called,
from.
What'd you call it? Would you call it course acquisition?
Yeah, that's one part of it, but yeah, that's essentially the mechanism, right?
Okay. So, can you repeat it? Repeat what you said. How does it determine it? All good.
Yeah. So the time, the signal has a particular pattern, and you can work out the time based on the pattern plus information in the signal. But ultimately you determining the time of transmission and the time of reception.
But don't you agree that like it needs to okay, you're sent this like string of information and it just repeats like every millisecond or whatever, right? It just has like a rhythm to it. But that like to turn that into a position, then it needs to take the arrival time and run it through the downloaded satellite position right? And that comes from the ephemeris.
Yes, that's right.
I think I have a better way, and which is going to get mad, but I think like sound propagating through a valley is I think the easiest way to explain it. So if we imagine that we have people living in a valley that's like 20 miles by 20 miles, right? Like a valley in Arizona or something. And there's a cannon on the hillside that goes off and people can hear that cannon for 20 miles. And cannon's going to be heard for that long anyway. They can, right? Now, if you have three observers that all have a synchronized watch, and then we know that the cannon is going to go off at a certain time, they can use that timing to figure out how far away the cannon is from their location, and that would draw a circle around them. And if you had three of them, they could trilaterate where the three circles intersect would be where the cannon is. Now you can add a whole bunch of other people all over the valley. They could all do the same thing, and their circles will all trilaterate on the same thing because based on the physics of that sound wave propagating through the valley. And what Daz is trying to tell you is there would be no way to fake the position of where that cannon is and still have everyone in the valley be able to use their timing information and accurately have a solution that trilaterates where that cannon fired.
That's not in any way an adequate analogy. Do you not understand why?
No.
Driving triangulation. I think you got it there, Jake.
Do you understand why?
No, I don't understand why that's not a good
Okay.
analogy.
We're talking about satellites and the receivers that receive the signals of satellites, and we're talking about nanosecond differences using clock synchronization to properly determine and interpret the data to know the exact time it was received, thus reversing, basically finding out what the distance is in relation to one another. So some crude analogy about sound waves in a valley is in no way going to answer my question about the veracity of the clock synchronization determining the exact time in relation to the other receivers. And from what I heard was that, well, you don't need that. You can receive it on your own and record all of the different satellite signals simultaneously, and then determine which one was which, and then know when it was received. Is that right?
Yeah. Yep.
Everything
So you still have to solve the time, right? Yeah. But I don't understand why you're so upset about nanosecond precision.
Well, because it's obvious that with something that small and that precise, that if there is any type of corrective factor, any type of synchronization methodology, which there are, and there are multiple ones, and it's highly complex math, and I find it hard to believe that maybe you are familiar with it, but whenever we looked into it, it's like, bro, the amount of different things that they run through this data through to get the output is insane. Okay, and it's like
for two
I just wrote a bit of software to do this, right?
For two receivers that are thousands of miles apart, it could be tens of milliseconds difference in that signal. It's not just nanoseconds. Yeah. It can be tens of milliseconds.
Now we're back to thousands of something where you can't determine the distance and verify the distance on the ground, but you need that to even make your argument in the first place.
And by the way, for 8-meter accuracy, that's just like 20 nanoseconds, which is like 30
megahertz.
That's how fast computers were, like 40 years ago.
That isn't the point. The point is that it runs it through synchronization processes.
Well, it has to be distinctly pre-calibrated and corrected for the potential that it's going to be operating at,
right?
and the velocity that it's going to be operating at, which actually refutes relativity Strong's equivalency principle as well.
Relativity is not pertinent to this conversation.
Oh, that's convenient. Because for it to even be moving around what you claim it is, it needs to be relevant, but whatever.
But
can we agree on a few things?
You're missing the fundamental, right?
We can't invoke this proof, quote unquote, with vast distances between the receivers because we need to know the distances between the receivers in the first place. So for starters, to actually test this in reality, we're going to need to empirically verify the distance between all receivers. It needs to be localized enough that we can do so empirically, right? Because if we just use the very coordinate system and distances that we're supposedly about to prove, then that just makes no sense, right?
Hundreds of meters or miles, we can establish straight line distances through the air quite straightforwardly. So you put two receivers on two mountain peaks, 5 miles apart, you could measure the distance very precisely.
What? Like with the duration of signals of radio transmissions vary all the time.
Yeah, but that's you'll see the variability, and if you've ever played with GPS decoding software, there's quite a lot of variability. So this doesn't happen with, it's not a one shot, one point in time fix. It's got to it's got to converge on the solution over a large number of messages. But
the solution's conveniently predetermined by the globe, right? So
the variability in the propagation, you need to be able to resolve that as well. So that's why they have dual frequencies, for example, so that you get two different propagation effects for the different frequencies. So you can eliminate some of the things. And going back to the RTK solution as well, that eliminates nearly all of the unknowns in GPS. But going back to the original point, there's no mathematical thing you can come up with, the stuff inside the GPS that will give both internal consistency of the solution and external validation of the solution in reality between receivers. Regardless, even if you turn off, you have the crudest receiver possible that just simply uses the course acquisition code and uses the synchronization that it has with the course acquisition code and the timestamp to determine the position.
Okay.
You'll have a 10-meter error. You'll have a 10-meter error in any given position, but if you're 500 meters or a kilometer apart, that's more than enough to start to be able to determine whether or not those XYZ coordinates are lying on a plane or a sphere.
You agree that before the signal is sent from the satellite, it is going to go through a correction, one of which is based on general and special relativity, where like a clock orbiting a globe will tick faster by however many thousand nanoseconds based on the mass and radius of the Earth. Okay. That's going to happen before
How does
they
that
ever send
alter
a
what you
signal.
use?
Do what?
Sorry, you go. No, you go.
That's just going to happen before. That's going to happen before the signal is ever sent out from the satellite, right? So you're measuring a wave that was slowed down on the ground to compensate for their basically their gravity model. Like the globe is like hardwired into the signal itself.
It doesn't matter what has happened at the instant the signal is transmitted. It is what it is. It does not get manipulated as it travels through the air. Everybody gets the same signal, and the time of arrival of the signal between different receivers is precisely determinable. And you can effectively reverse trilaterate the position of the satellite by using multiple ground receivers.
I see that part again?
Knowing the ephemeris. So if you don't know the satellite ephemeris and you've got a bunch of ground receivers that understand a little bit about the GPS signal, like how to get time out of it, you can actually trilaterate the position of the satellite from the ground.
That doesn't help us.
It does, because it tells you that just based on the time of arrival of the satellite, of the signal, you can determine where the satellite is.
Got to have a flat baseline for that.
Nice one. I'm going to drop anyway.
Well, I'm just trying to understand why we're bringing up the ground stations now.
Because the multiple, when I say ground stations, meant ground-based receivers. So multiple ground-based receivers We'll all get that different. We'll all be can work together to determine where a satellite is. Basically, if they don't have the ephemeris, they can actually calculate the ephemeris by observing the time of arrival of the signals. That's like three-dimensional Iran.
Right, but in order to do like inverted trilateration, you would need to know like the exact coordinates of the receivers on the ground.
Not just relative to each other. So you can make a local coordinate system that is only known to those receivers, and you can work out the position and the path of the satellite through your coordinate system.
Yeah, you need to know exactly how far apart they are to get a geometric baseline, but like,
Yep.
That's
Yep.
Yeah.
That's not hard to do, right? That's a well-established thing too. We know how to precisely measure short distances on the surface.
Wait, come out. This has not been done.
Why? It's effectively what ground stations do all the time. That's part of the way they work.
Ground stations are not super close to each other.
No, but they have receivers, multiple receivers as well as the ranging information. Yeah, and yeah, they're doing all the tricks to work out where the satellite is.
Ground stations
Based off
use
sea
like
level.
realistically.
It's based off sea level, right?
Well, realistically, ground stations are gonna use their WGS 84 position.
Yeah, but even if they're like a few miles apart, you can accurately establish the distance between them without any ambiguity. The difference between the coordinate.
The assumption you've got there, though, is that sea level is curved, not flat. Like that's your
It
assumption.
doesn't matter. You could do this just assuming a flat Earth, right? So you could put a network of ground stations down, measure the distances, assume you're on a flat plane, and if you lay them out in a triangle or something, equilateral triangle at equal elevation, they are in a plane, right? And you can measure everything relative to that baseline that you establish.
The distance between a flat Earth and a globe over 69 miles is like 4 or 5 foot. So y'all act like this couldn't work on the plane, dude. I don't know, man.
No. But that distance is.
They're not taking. Hold on. They're not taking very steep angles. I mean, if a satellite's a certain distance away, there's a certain limit to the how steep of an angle they'll take. And straight above is really the only one that can be proven with all this reverse triangulation you're talking about would be one right up above or damn nearly right up above. So I don't know, man.
You'd be tracking the whole flight.
The only thing I disagree with is the fact that it doesn't prove a globe. That's the only place I would disagree completely with what you're saying. But I agree with most of what you're saying.
I think this backfires a lot though, because like you're talking about reverse trilateration with ground-based receivers, right? So you have like they have to all be like synchronized. The exact same clock.
Same deal. Establishing time sync between ground stations is also a solved problem.
You say that, right? Do you agree this carries over to like individual receivers as well?
It carries over to what? Sorry.
This is the same. This is the same requirement for all receivers. They need to be synchronized to the exact same clock.
Yeah. So an individual receiver only needs to be synchronized with itself and the satellites. But yeah, to do multiple satellites, multiple receiver synchronization, you need to be able to synchronize them all together. But that's the same deal. You can do that offline. You can just record the data. There's enough information in the recorded data to cross-synchronize time between a network of satellites, a network of receivers.
But the fundamental baseline has to be the same, right? Like you have to have a synchronization of the same clock, and the way that they do that, like practically actually accomplish that, is they use like a network, right?
Yeah,
and they
but how do they fudge the clock
Sagnac corrections,
for individual
bro.
receivers?
What's up?
How do they fudge the clock for an individual receiver?
Well, fundamentally, what do you mean for an individual receiver? They sync it to a network. What's the individual receiver synced to?
No, the individual receiver syncs to the satellites. So
but the satellites are synced to what?
They've got central synchronization. Their time sync is managed.
So here's what I'm saying. At that
same
central synchronization, What's up?
Yeah. But that only makes the problem worse. If they are fudging the time for some reason, that will make the ability for so if they're fudging it in a way to fake the shape of the Earth, is what I'm saying. That will make it even harder for individual receivers to get a position lock in the first instance, and almost will it make it impossible for them to get a position lock where the distance between them is consistent as well. You can't fudge it at scale.
But maybe
I mean, all the receivers are synced. All the receivers are synced, and all the ground receivers are synced. All the ground stations are synced. The satellites are synced, and they use a central network system to do that. And it has multiple corrections. One of which is like the Sagnac effect, which aligns the clocks.
So the satellite clocks do need to be adjusted, right? I'll guarantee. I'll give you that. But it doesn't alter the fact that once the signal has left the satellite, there is no alteration happening.
No,
So
but the receiver.
The time of the arrival at the receiver is purely and simply a function of the propagation time of the signal. There's nothing you can change between the satellite and a group of ground-based receivers that will cause them to get a time of arrival that corresponds to any particular shape of the Earth.
Yeah, yes, there is. The time that it sent it. You change the time that it sent it.
No, Brian. It's sent. Everybody, it is sent once, and everybody receives it at a particular time after it is sent. You cannot fudge the time of transmission for an individual receiver. The only way you can change the time of transmission is by changing the physical distance between the transmitter and the receiver. And there's nothing else you can do to change that time of flight. So it doesn't really matter when it was actually transmitted.
Dude, that's what I said. You're saying you change the time.
The difference.
Hold on. I'm saying change the time. If they're adjusting the time, adjusting the clock for these corrections, then that's it. That's to answer your question.
So if they're fudging the time, then they transmit the message. My receiver A gets it at time 0, and receiver B gets it at time 0 plus 50 nanoseconds. The only cause of that extra 50 nanoseconds is 50 nanoseconds of transmission through the air. There's nothing they can do in the satellite to make my other receiver get the signal at a different time.
Bro, it's just begging the question, dude.
Well, that's not what's needed.
It's not begging the question. Can you explain how one signal can arrive at different locations at different times, and where am I going? Yeah, so one signal arrive at different locations at different times, but the distances between the source and the destination aren't consistent with the travel time.
You're going to have to repeat that question, dude.
Yeah, that's fair enough. It didn't make any sense to me either. So if you've got a single signal being transmitted and it's propagating through space, and you have a number of receivers picking up that signal that are time synchronized, how can we fake the time of arrival of that signal to those receivers? We can't. Once it's left and is in transmission, we're up to the laws of nature for that signal to arrive.
Yeah, but how do you know
when it arrives?
How do you know? Yeah, how do you know when the signal left the satellite?
It doesn't matter. You can work out the time difference in arrival. So if you know the difference in time of arrival, you can draw like a big triangle. And if you've got 3 or 4 or 5 different times
answer
of
the
arrival,
question.
3 or 5.
How do you know when it left the satellite? How do you know what time that was?
Yeah, they can alter. They can alter timestamps.
And you have to know that. You have to know that.
You don't have to know it to work out the time difference of arrival.
Wait. To turn the time gap into an absolute distance, then you need to know when the signal was sent from the satellite.
No, you only need to know the time difference of arrival to work. So this is not about solving the trilateration distance. This is about working out the relative distance between two receivers. So if receiver A gets the signal then a fraction of a second later receiver B gets it, that fraction of a second is proportional to the difference in the distance between the
That's not going to
source
help you
and A and the
probe. That's not going to help you
no,
prove a
this
globe.
well, it will eventually, Brian. It shows that you
What?
can't, once the signal's in flight, time difference of arrival between receivers is wholly dependent on the geometry of the transmitter and the receivers.
I just want to point out how much more cordial it is when there are like multiple flat earthers trying to talk to a glober.
Anyway,
But
I've got to
okay,
drop.
so okay.
If you got one more question, I can hack it. But yeah,
Well, I'm kind of confused. We bounced around a bit, right? Like, so if we're not doing the reverse trilateration now, we're just determining the distances between the receivers themselves, but the clock synchronization doesn't count. Whether or not the satellite bakes in the Sagnac effect and other relative corrections, and then that corresponds to the program that's in the receivers that then have to make a phase correction with the ambiguity of the signals, and then we know that it does that, and it linearizes it and then corrects it. None of that matters. You're saying that we can individually measure and verify and physical distance empirically with receivers on the ground that are in close proximity to one another. We can then individually measure the time of arrival outside of the receiver itself. We can independently measure that. We can measure it from all kinds of signals at the same time and then determine after the fact which one was from which place. Then compare all the different receiver signals that we independently measured outside of the software corrected receiver data. And then we can compare that to the empirically independently verified distances between the receivers. And that when we then do that, the math will only work for like say all 4 points on a sphere down to like the nanosecond accuracy of the, or like say it's like
no,
microsecond, because microsecond
no,
is like
you
300
drew.
meters or whatever.
Yeah, no, you drew the wrong conclusion. We can prove that GPS gives geometrically correct positions. That's all we can prove from that scenario. So we know time of flight, position of all the satellites, and relative time of arrival on the ground, relative distances on the ground. That lets us verify the geometry on the ground matches the geometry in the sky in terms of being solvable and consistent. Then we can start to move around the ground and measure the geometry of the ground in that system that we've determined is consistent and correct.
It's like you've made multiple different arguments, right? Like now we're talking about like inter-receiver distance.
Yeah, so
But
this is the distance between the receivers on the ground, right? That where we work out the time
yeah.
of arrival difference, right? So having a time of arrival distance is of no use if we don't know how far apart they are.
Oh, I agree. This is why, like anyone invoking like vast distances, it just begs the question. It's circular because the distances are what's in contention.
Well, the vast distances, what you'll find is that as you, so if you got a GPS receiver and locked it on and were able to communicate with another GPS receiver over infinite distance, you would find that as you moved, if you measured your distance along the ground as you went, that your coordinates would be very consistent. So the distance that you've measured as you move along between you and the other receiver would remain consistent, independent of distance. Until you started to go around the curve, of course. But anyway, I've got to go. Sorry, guys.
Take it easy, man.
There are backup GPS systems that don't rely on satellites, and they're pretty accurate.
Yikes. Kept trying to talk and I wasn't coming through. That was so annoying. Whatever, man. I had questions for this guy. All good. We could have kept going forever, I guess, because like, if you go from A, if the signal hits A, then signal hits B, right? Like receiver A, receiver B, then you're gonna use like a hyperbola, right? Like it's gonna be a mathematical curve to define like the difference between the two. And so then you have a third one, you're gonna have another one. And this is just like intersections in like 3D space. You know what I mean? It's not nothing to do with the ground, which ultimately at the end he ends up admitting that, but whatever. And like, dude, from my understanding, a lot of the stuff that he was claiming is like exclusive, or they were claiming it's exclusive. Like there are systems that they use that don't use satellites at all that do the same stuff. Like I can't remember the name of them though. Like the military uses them. They use them in like certain coal mines and stuff like that.
Loran? Oh no.
Now Loran is older, but there's like astronomers use one of them. Like there's like these radar systems, and they use like high altitude blimps, and like even like ground based drones, and they're able to like precisely determine and calculate 3D position of like of an aircraft, but they treat the ground like it's completely flat.
To me, they got to. If they're using actual signals and not fictitious orbits, like uh, assigning it.
It's just like if it's just doing it in the air, it's like where 3D points like meet, match, or intersect in the sky, then it has nothing to do with the ground. Maybe that's like for like reverse trilateration, like he was bringing up a second ago. I don't know. Anyway, what I do know is like you notice how quickly it changes from like everybody can do it, everyone who's got a receiver can go do it. They're all proving the globe all the time. The fact that you get it and I get it and he gets it and they get it and they get it, everyone can just walk outside and do it right now. We can just prove, we can know our distances, we can compare the time we got the signals, and we know for a fact that it proves the globe. None of that's real. Quickly it turned into we got to be in a small field just a few hundred meters away from each other. We empirically measure our distances, and then we don't actually use the receivers, and the time that they register when they receive the signal, we'll go independently receive it and measure it ourselves, and we'll measure it at that point in time. It'll get all the signals from all the satellites. Then after the fact, we'll sift through it, we'll pick the different ones out, then we can reliably compare the different signals to each other. It's like, whoa, wait a minute. This is just like we were talking about what started all this, which is determine the distance on the Earth. And like, how can you actually reliably verify the distances on the Earth? And we're talking about a boat. And it's like, oh, cruise ships go to Hawaii all the time. And then it turned into like, you can measure the speed of the water. Well, you can do this. It's like, we don't do any of those things. So my ultimate follow-up question is like, okay, you guys are super confident. Can you guys show me someone doing this methodology that we've now boiled it down to needs to be done for starters? Because I still have a lot of contention with it, issues with it, because like I know that every time I sit in on one of these conversations but I don't talk, all those details I brought up never get brought up, right? They don't ever bring up the phase ambiguity. They don't bring up the fact that like there's a linearization of the data, and then there's like a phase ambiguity, meaning like they act like it's perfectly in phase. They know exactly when the signal receives. That's not what happens at all. They don't know when they receive it at all, right? And it's like there are like hundreds of thousands of possible solutions or whatever, and the program is gonna like solve for the phase ambiguity in its highly complex systems, and they could not get them to work, and they had to bring in Ron Hatch, who's a geocentrist and an ether proponent, to fix it for them. And he writes about how like, dude, the reason it didn't work is they're non-inertial frames, they're relativistic assumptions, they don't work. And I had to basically build a corrective model for the phase correction based off of my like an etheric understanding, completely throwing out the idea of relativity.
Show us the model, Witsit. Show us it.
Ron Hatch did it.
Oh, Ron Hatch's model. Yeah, I've got his phase model in my solution. So.
Let me say this.
Well, Ron Hatch writes a book about it. You should read it if you never read his book, because his book is pretty crazy, bro. And like we actually, my buddy went and bought it. It was like $300 or something crazy, because you can't buy it. And then he took the time to like individually scan each page. So we do have a PDF of his book, and it's pretty crazy, bro. Like the stuff that he writes and claims, it's like pretty crazy. And like when every time we dive into satellites, we're like, dude, no one talking about this or using this knows any of this stuff, bro. Like it's insane. If you just talk about the phase ambiguity issue, there are so many equations and calculative corrections and stuff that runs through that it's like mind blowing.
It doesn't make it impossible or incorrect, though, right? It just means because you don't understand it doesn't mean we have to reject it.
No, but you don't understand it, so you can't know it's real.
The software that I wrote has Ron Hatch's phase filter in it, the Hatch filter.
Yeah, but if you're using if you're using Earth center, Earth fixed, I mean, if you're using the center of Earth, then the elevations are ambiguous anyway by assigning the satellites radial orbit and using the Earth center. Then, I mean, what does that tell you? Like I said, it's a good system, but it just doesn't prove a globe, man. That makes the elevations ambiguous, man. I mean, maybe not ambiguous ain't the right word, but it makes them relative, basically, to a planar math. The math would be the same, dude.
Sorry, I missed. I'm not sure what you're talking about.
Yeah, dude, I'm proud of that one, man. Like I pointed that out to Bob No a long time ago, man. And I didn't realize how important it was, but I knew it was important, you know, seeing the Ron Hatch. He understood it better than me at the time, probably still. Well, not still, because God rest his soul. But yeah, and then y'all took off with it, man, and helped me understand it more. But dude, the more I understand about that, the more I'm like, whoa, like that's some complicated shit, dude. The corrections. There's so many corrections. It's crazy, man. There's some patient people to sit and work out all that shit.
Things based on complexity, you're completely dismissing and omitting the complexity for the desire to present a geometric proof simply. If it were that simple, we wouldn't need all this complexity. Why does all this complexity need to even exist?
For precision. The overall solution doesn't need the complexity, but for precision, you need the complexity. The outcome of whether or not GPS shows the Earth curved or flat is not dependent on all the complexity.
Well, that's what you say. So have you done all these things that you claim that we can do to prove it?
I do. I'll paste you my Hatch filter. Give me 2 seconds.
I understand. So like you've had multiple receivers in close proximity that you independently measure the arrival time for each of them and then compare them to the independently verified distance, because realistically, bro, come on,
Yeah.
like you haven't done
So I used. I have limited access to raw receivers, so I had to rely on what I could get. But I have software that takes the raw GPS measurement from 2 receivers. So the raw GPS measurement is just a time-stamped. I guess it's a pseudo range. So it's the local time of the receiver and the time that all the signals arrived. And where the signals were in their transmission phase. So you get this snapshot of what landed on the receiver at a given point in time. So I've collected that from devices at known distances apart, and I've got software that takes that and uses solves for both systems and calculates the distance between the 2 satellites, both based on their individual solution positions, but also based on the time of arrival difference. And it is complicated, but it is doable. Don't eliminate something because it's complex.
No, I wouldn't do that. If I was going to do that, I wouldn't have sat here and talked to you this whole time, would I? I like if the mischaracterization of my approach to this conversation were accurate, I would simply throw out some of these buzzwords and point out some of the corrections and run away. But I am thoroughly convinced that as we get to the bottom of each and every component of this, we're going to find out that for some very interesting reason, there's a reoccurring theme that the data is cooked. So it's like, bro, I mean,
I still don't understand why you can't understand that you cannot fake the propagation of the signal over time.
Okay.
The signal.
When did I say you can fake the propagation?
But like Dazza has been trying to explain to you for the last 2 hours or hour or whatever, there's no way to have the receivers agree on a solution on a signal that's sent at a simultaneous period of time that propagates to all the receivers at a different, with a different time delay, and have a logically consistent answer amongst them.
Well, no, they have to have, first of all, they have to have different arrival times, and like honestly, respectfully, I doubt that you could stillman what Daz's final presentation of the argument is. Because it's not what you say, and it's definitely not sending sound waves in a valley.
The sound waves in the valley is
I
just
think
an
you should
analog
save
to the propagation of the signal, of the radio signal.
Save the whole I can't believe you don't understand it stuff.
You clearly don't, because you keep suggesting that it's mathematically possible to spoof it, and we're telling you that it's not, and you said that it is possible. That's why Dazza said, well, then show us mathematically how you could have the receivers agree on a solution that are separated in physical reality by a physical distance that has a radio signal that's propagating based on the laws of physics at a known rate, and have them still arrive at the correct solution.
Well, you just assume you want me to just grant you the inputs. You think I don't understand the argument because I can test the inputs?
How do the inputs manipulate the outcome in this situation?
Because if you know what the relative positioning times should be, and then the software takes the data and spits out those times, then all the rest of it means nothing to me. And this idea that you can go out there with a receiver and you're going to know the difference, you would never know the difference. You would not know the difference in what signal you would receive, what time you would receive it on a flat Earth, a globe Earth that's twice the size, 1,000 miles away. You would not be able to tell the difference between what time a signal received, what time you arrived, 500 meters away. You would never know. You're relying on the actual receiver reading that signal in that phase to tell you the specific arrival time.
Yeah, but I think you're missing the point. So this validation between external receivers and the GPS constellation demonstrates that the solution is consistent and can't be messed with, right? And then what you do is you move those receivers. So then I guess you have to make the assumption that GPS is still working as it was when you tested it, and then you place those receivers along a level surface and measure their XYZ coordinates, and that level surface will show as being curved. So there's two phases here. One is to prove that GPS gives you a geometrically correct XYZ coordinate. It can't be messed with without consequences. And then you can show that those XYZ coordinates, when on the surface of the Earth, fit a sphere.
Well, the contention, of course, are the coordinates themselves.
Yeah, because hold on, we know GPS
the actual
positioning.
coordinates don't matter. The XYZ coordinates are where their origin is and stuff is kind of almost irrelevant, provided we have an XYZ coordinate system that we can trust.
Well, that we can trust is the reason.
And that's what we're trying to do with this other test, right? Is show that the GPS is what it's claimed to be.
Yeah, but that's the whole point, right? Like you're claiming we can trust it because we can go use it on Earth, and it'll actually know where I'm at, and you think therefore you can trust it. But that's not how that works at all.
But it knows.
We went through all of it.
But how does it know where so GPS doesn't know where you are, right? Your receiver works that out. And we're working this out in ECF. So we're not doing that long. We don't give a crap about maps here. We're just working out. So we're comparing local geometry measured by GPS with the overall GPS system. And if GPS measures local geometry correctly, and we can extend that concept of locally very far, then we'll be able to determine whether or not GPS is capable of measuring our position accurately over large areas.
I mean, well, respectfully, I'm not gonna go back through like why we can't trust the XYZ coordinate claim. Like, I mean, I already went into depth. There was no sufficient rebuttal to it either. So, I mean,
other than we just demonstrated that you can't fudge the XYZ coordinates without the fudging being obvious.
Did we demonstrate that though? Because we invoked something that no one ever does in reality, and then made the claim that we can reliably, precisely determine the arrival time without having to make any type of phase corrections, apparently.
Yeah, we don't have to worry. Phase correction is a high precision adjustment, right? It takes you from multiple meters down to centimeter kind of level, or very high precision, and we don't have to use GPS phase information if we don't want to. But the phase ambiguity problem is easily solved, right? The biggest issue with it is how quickly you can solve it.
No, it's not easily solved.
No, it is. It's not. It's almost trivial, right? You can do it by brute force if you want to. So if you've got a series of GPS measurements, so just the time of arrival, the raw signal on your receiver, and you want to work out the phase, basically you have to just brute force testing different phases based on an initial guess until the solution locks in to a precision solution. A whole heap of things in maths and science and engineering are solved by these iterative processes, and it's just because it's some variable you don't know, it doesn't mean you can't solve for it and then be confident in the solution.
I don't even know how true this is.
So if the phase is wrong, right? If you've got the wrong phase information, your GPS, your actual location fix will have a large residual error in the numerical solution, and that will show up. So you'll know that if your phase is wrong, your error margin, you've probably seen it on your phone, that the little circle around your GPS location gets tighter over time. And that's because it's resolving phase ambiguity. It's resolving other errors that it knows. It's improving its estimate of time as it goes on. And that circle effectively represents the mathematical residual from the solution. So you can self-check whether or not you've got a good, reliable set of variables that you've understood.
I asked Gemini, could GPS signals be manipulated to make all receivers believe they are on a globe when in reality they are on a flat Earth? If not, why? And it says GPS does not function by having satellite broadcast messages like you're at X and Y. Instead, GPS is a passive, purely physical time-of-flight measurement system. To fake a globe on a flat plane, you would have to break fundamental laws of geometry, speed of light propagation, and physics. A GPS receiver determines its location using 3D trilateration. Each satellite broadcasts a precise timestamp generated by onboard atomic clock. Receiver. Okay, I don't need to get into details. On a spherical Earth, the physical distance between a receiver in London and 4 specific satellites form an exact set of intersecting spheres that all converge at a unique point in 3-dimensional space. On a flat plane, those physical distances between the surfaces and between the surface and the satellites in space are completely different. If satellites altered their timestamp signal to try to fake a distance for a receiver in London, that modified timestamp would simultaneously reach receivers in Paris, New York, and Tokyo at the wrong times, causing their receivers to produce mathematically impossible distance calculations and fail to establish a location fix. This is everything that Dazza has been trying to tell you all night long. It's mathematically impossible based on the physics of 3-dimensional space and the propagation of light.
Well, let me tell you something. I just figured out when I asked, could the raw data from GPS be mapped onto any shape? Yes, the raw mathematical data, the XYZ coordinates, can be mapped onto any shape that can be described mathematically. Once the GPS receiver calculates your exact location as 3D coordinates from the Earth's center, that point is fixed in space. You can overlay any shape onto the same center point and calculate where your position lands relative to the new shape. Here's how the difference, blah, 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 goes on to map the exact raw data into a different shape. Flat planes, 2D shapes, the process, the result, it can be mapped onto any shape.
Yep, there's no disagreement here. Now go ahead and ask it. Now go ahead and ask it and read us the answer. However, could the position that is arrived at by the GPS satellites be manipulated in a way to allow for the Earth to be flat, when in reality it's on a sphere, and have the receivers agree?
Incoherent straw man question. You already read your whole straw man. Do we gotta hear you try to get him to do it again? Okay.
I mean, Witsit, you think it's mathematically possible?
Oh,
you think it's mathematically possible to do this?
Dude,
do you think it's mathematically possible?
Oh
yes
my
or no?
God! Why are you interrupting me? Why do you think you run the room? You don't run the room. He literally is interrupting me. I was talking and he interrupted me. No, that's not how it works. You have no
Jake,
juice.
You proved your point. I mean,
you got muted again. I'm the one who unmuted you, and you just immediately got muted again because you're acting crazy. I didn't mute you, but this is the thing, right? I went to answer him. He immediately interrupted me 2 times. Then you jumped in to say you proved your point. It's just ridiculous. So again, I'm going to address the actual point because you're claiming that you want to keep on doing this character. I guess you've been doing it for 4 or 5 years. Flat earthers don't even understand what we're saying about the math. I still manned it better than you did 30 minutes ago. So why do you keep jumping off your mic saying, do you not understand the math, Austin? I can't believe you don't understand the math. Do you not understand the math? I already still manned
because you keep claiming it's possible. You keep claiming it's possible. If you understood the math, you'd agree that it's impossible.
Incorrect. I understand.
Then go ahead and show us the math of how it's possible.
Dude, why do you keep doing this?
Would you be willing to take a bet that you cannot mathematically prove it to be possible? Would you be willing to take a bet? We could do it in Bitcoin. I know you need some money. Would you be willing to take a bet that you cannot mathematically prove it?
Jake,
you're so terrible.
Is it your goal to reach a good faith conclusion here? Or is it your goal to just continue down this route?
Yeah, just don't interrupt. Let's continue. Let's try to.
Okay. So everyone understands the math argument. And I've said it multiple times. And I've even conceded to it. That's how I brought the whole conversation up, conceded to it after still manning it, and then proceeded to have the conversation to get into the specifics that you all assume and think you know, but you don't know. You haven't responded to any of that, though. For example, you keep talking about just based on the propagation of light. It's basic physics. No, it's not. You don't know what you're talking about at all. So in your paradigm, there's an ionospheric propagation delay. Every single satellite signal comes through the ionosphere. It intersects with the ionosphere. There's significant delays. It fluctuates consistently. You can't just go read the raw data, which is cool. I guess we'll just make up stories like we all live in like cartoon land and everything's super simple so Globers can make arguments or whatever. That's not how it works in reality, though. You can't just go read the raw data. We don't need to know that the program doesn't need to make the corrections. We don't need to solve for the phase ambiguity. It doesn't even matter. We can just read the raw data. That's not how it works at all. In fact, GPS wouldn't even know what continent it was on if you didn't correct for it based on your own model, who's claiming that there's ionospheric propagation delay. We didn't even get to that part. You guys can't even get through the fact that there is phase ambiguity. Can you respond? If you want to talk all tough, let's go ahead and play tough. Respond. Okay.
How much does that throw off the accuracy of the solution? How much
Why are
does
you asking?
how much this ionospheric propagation delay throw off the solution? How
I can throw
far
it
does it
off a
throw it
ton.
off?
Something
How
as small
far?
as 100 nanoseconds starts to throw off the thing by what, like 30 meters or whatever. It can do it. It can do it by multiple microseconds.
Microseconds?
Yes. And it's this is what's so bad about it. It fluctuates in your model. So the frequency fluctuates, the altitude fluctuates, the depth of the ionosphere fluctuates, and your model also claims that there are density clouds that are seasonal. So according to your system, according to your model, there should be delays that are relative to solar motion and daytime. The satellite shouldn't work as good in daytime. It shouldn't work as good in the summer. The timing should be less reliable in the summer. Is that the case, Jake? Is GPS less reliable during the summer?
I mean, what do you mean by less reliable? What do you mean in terms of the precision of your fix? Yeah, the precision varies with the weather, with ionospheric events. Like obviously, there's a bunch of things that introduce error, right? That's why they have ground augmented GPS to try and that they use on aircraft for approaches where they need to have like meter precision. There are systems in place to deal with that.
What like what?
But when we're talking about solving a solution, all that stuff that you're talking about is not going to be throwing it off. Other than probably the most extreme ionosphere conditions where you could have like a millisecond or two of delay, and of course, like what Dazza was saying is those are transient, right? So you're not in the calculation, you're not going to get a fix. It's going to know to throw away that data because the data was bad, right?
No, what are you talking about? He's talking about just grabbing the raw data.
Well,
So
he
what
was
it
talking
does is
about
it would scramble the signal. It would scramble the signal. You would have no idea. So you guys like to do this thing where when we press you on the proof you're claiming, and it quickly turns into, well, you could do this and you could do that and you could do this. I've never done it. I've never seen anyone do it. No one's ever done it. We have no empirical evidence of that being done. We've definitely not done all of these. You could do this, 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 and this at the same time. We definitely haven't independently empirically verified any of it. But trust me, bro, you could do it. And because I believe I know that the Earth is what I believe it is, I know that if we did do it, it would work. You do the same thing with the plane, the same thing with the boat. You're doing the same thing with satellite. So can you actually show me someone doing all of these things you claim? Because you can't. You can't even reliably interpret your signal and arrival time in your own model without accounting for multiple things, one of which I've only named one. It gets way worse. I've only named one, which is the ionospheric delay. Is before we getting into the SAGNet corrections, the anisotropic corrections, multiple different relativistic corrections, the complexity of the phase corrections themselves, which require you actually throw away relativistic physics, which is why they literally had to bring in a geocentric ether proponent to do it. Okay, so like I just want everyone to remember, because what always happens is over time people kind of check out because it sounds like it's so hyper specific, so in the weeds, and we get lost in translation, and you guys just move the goalpost, and change your claim. Just a few minutes ago, we could just go take the raw data. We don't need anything. We don't even need to let the receiver take anything, because I'm like, yo, there's actually a clock synchronization that happens inside of the software of the receivers themselves. And of course, it's ran through this system that's synchronized everywhere from the satellite itself. It's sent to us. So the ground station runs into the WGS84, the ECF, which is built off the WGS84, the globe coordinate system. It runs it through the ephemeris, which is actually based on the Keplerian orbits, which take the center of gravity, which is the center of mass, which is the center of the globe. Then it takes the inclination angle, which is the tilted angle in relation to the center of the globe. It sends that signal up to a satellite. That satellite sends it down to a receiver, and after it runs it through all kinds of relativistic corrections, Sandnet corrections, clock synchronization corrections, sends it down to the receiver, and whenever there's a discrepancy based on the phase ambiguity, it has to run it through multiple corrections. There's thousands of possible solutions to the equations, and then it does the ambiguous clock synchronization corrections as well. And this is not even accounting for how it needs to apparently account for things like ionospheric delay and interference. And that right there is an entire mountain of problems for you, because supposedly it fluctuates its altitude, fluctuates its frequencies, has density clouds that go up to 300 megahertz, fluctuates the depth of the interference with the signal before it receives to it. So how could you possibly know? We're talking just a second ago, we had receivers that were only 500 meters apart. Now we're talking about a 100 nanosecond discrepancy, which is easily predicted by typical ionospheric delay, not even the severe conditions, which can amount up to like 150 to 300 meter discrepancies. So, but just a second ago, we need to know exactly the distance between the receivers at 300 meters. I mean, at 500 meters. Now all of a sudden, a
How much
typical
error is
day.
there? You just said 30, 15 to 30 nanoseconds, which I agree with. That's pretty typical.
Well, I said 100 nanoseconds.
Okay, well, go to 100 nanoseconds. What is that in distance?
30 meters.
Okay, you just said 300. So 30 meters is what? Not even like a third of the way across a football field.
30 meters.
And Dazza was talking about setting up receivers 5 miles apart, right?
No.
That's like 7,000, 8,000 meters, right?
No, he was talking about 500 meters.
Even 500 meters, right? That's still an order of magnitude more than what that 100 nanosecond error is going to cause, right?
That's the low end, right? Like you easily get up to like 150, 200 meters with ionospheric delay.
Only under, well, again, 100 to 200. That's not that big of an error.
So we have 4 receivers separated by 500 meters, and each of them can experience well, I would say isotropic, meaning like there's no preferred direction of the error, because the signal's just getting scrambled. The error can be in all directions. So say this receiver is going to go 150 meters to the right. This one's going to go 150 meters to the left. This one's going to go 150 meters north, so straight, right? Now these receivers are way further away from each other, but 500 meters. But then we're going to turn around and use hyper precise nanosecond measurements to determine the exact location, and then we're going to be able to determine that it's spherically exclusive. How in the world is 150 meters out of 500 meters insignificant?
Again, 150 meters now. We were talking about 100 nanoseconds, right? On the upper end of this error.
No, the lower end.
No, the lower end is like 15 to 30. The upper end is 100, and then if you're talking like, and now if you're talking like 300 plus, you're talking about like a geomagnetic storm. You're talking about something extreme.
Okay, yeah. So like
on an average day, you're talking about 50 to 100, which is what?
Okay.
30 meters.
No, I'm saying okay. Say 50. Let's just say 50 meters. Let's just say that it's 50 meters for each receiver. We have 4 receivers that are separated by 500 meters each. 50 meters in all directions, no specific direction for each receiver, drastically changes your ability to now take the duration of a signal, the time arrival of each of the receivers. This is, let's set aside all the problems with X. We'll bury that in just a second. Just assume that you magically can do what you guys can do, what you literally can't do, and the ionospheric delay disproves that as well. Just pretend that you can take the raw signal. You wouldn't even know what continent you're on. Anyway, so just say you can take this raw signal that gets scrambled and somehow magically read it with raw data or whatever. Now all of a sudden, it doesn't matter if there's a fluctuation up to 200 total change in like net meters in distance. That doesn't matter.
Yeah,
So you can still prove
because
it's
your
like
signal to
reliable
noise
and it's
ratio is
slow.
an order of magnitude different, right? So and that's assuming 500 meters, which is like completely arbitrary. Why would you just do it at 500 meters? Obviously, you would want a bigger distance than that.
Well, you
But
have to
even at
independently.
500
You have to be able
meters,
to
your signal
empirically
to noise
verify
is
the
still an
distance.
order of magnitude different. So it's
You understand? You
easily.
have to be able to empirically verify the distance, right?
Yeah, I think you can empirically verify 5 miles pretty accurately, don't you think?
How?
No?
How?
You don't think that you can empirically verify whether something is 5 miles apart?
I think that we can get within the ballpark of 5 miles.
Within what area? Within what measuring accuracy do you think we can measure something to 5 miles
That's a
out?
good that's a good question. I mean, it would depend on let's say there's literally nothing there and everything's flat and you're making physical measurements, you could get a lot more accurate. If it's not the case and you're going to start using stuff like GPS to do it, then then we're in trouble, aren't we? And
Well,
realistically,
like you could use
this is
a total
this is a thought
station with a
experiment.
reflector target, right? Which will just use we'll just use a lidar, right? It'll just use
Wait,
a
real
lidar to
fast,
measure the distance. That's
real
going to
fast.
be accurate to centimeter accuracy, right?
Let's just acknowledge that this is completely theoretical. You guys have never done anything like this. You definitely can't point to it being done empirically, and you have no actual proof of the thought experiment you're trying to present to us as proof of the globe. Can we just go ahead and get that covered real fast?
Because the only people that actually think that there's some kind of lie embedded in the GPS is just
No,
flat
no, no. That's
earthers,
a straw
right?
man. That's a straw man. Some type of lie embedded into it. Like this idea that we're just these schizophrenic psychos that think that there's some Dr. Evil behind a computer system monitoring all satellite signals and actively shifting it and transferring it over from a flat Earth to a globe. That's not what we said at all.
Well, you think there's a global cabal of all the countries and governments and space agencies in the world that are all in cahoots on a
Dude, you're
global lie about the shape
spiraling.
of the Earth.
You're
So trying
spiraling.
to make it seem like your ideas are not that crazy. I mean, let's keep it in
Spiraling.
perspective. You think there's a global cabal hiding the shape of the Earth?
Spiraling. No, what? No, I mean, what? Only a handful of countries would even have to be in on that.
You
Well,
don't think
what do you mean
you
a
don't think that
handful of
Iran
countries?
knows what the shape of the Earth is? You don't think what India knows what the shape of the Earth
Dude,
is? You don't
most like Middle Eastern Muslims are flat earthers.
Incorrect.
No,
Scientists know.
the actual doctrine of Muslims in the Middle East is that it was spread out like a carpet. What does any of this have to do with anything? Who cares what Iran believes
Iran
about
has
anything?
put satellites in orbit, so I think they know what the shape of the Earth is.
Well, why would they need to know what the shape of the Earth is when it's just a projection transform, and then all you have to do is understand that you're using an Earth-centered, Earth-fixed system anyway, and that the Earth is stationary. How does that prove the Earth is a spinning globe?
They're
So
putting
we
a satellite in
use
orbit.
the
They'd have to know
Earth like
if the
it's
Earth is a globe.
we use the Earth like it's stationary, and
Not for
then
satellites, you don't.
yeah, you do.
Sorry. No, incorrect again. Nice try.
No, you literally do though.
You literally do not.
Yeah, you do.
No, you do not.
Okay, let's use
How
the
do you?
ISS for example. Let's use the ISS. Can you show me the math of how you can explain the ISS astronauts floating on the ISS on a spinning globe?
Can I show you the math? No, because you
Yeah,
will deny it all.
you
You don't do
can't.
math.
It's impossible to do the
You
math.
don't do math. You don't do the math.
It's
No,
impossible
I
to do
don't
the
do math.
math with that. It's
Oh,
impossible to
please
do the
do not
math
speak
without.
math with me.
Why are you
Do not
interrupting me?
speak. I've never seen you do math in
Here, I'll
your
show you
life.
the equation.
Dude,
Don't
these
worry.
are just ad homs. This is not good faith.
No, these
Show.
are not ad homs.
He
Ad
asked you for
hominem
the math.
to begin with.
For the math. If you don't have it, you can say I don't have it, or I can't rebut that point, or you can't bring it forth. But you've just literally ad homed 3 times in a row.
Well, if he's going to say math, then how come whenever I ask him for math, it never appears?
That's
What
also
math?
just a non sequitur, too cocaine. That's
Totally
just a mess,
sequitur.
dude.
Totally
It's
sequitur
completely
in this
non
case.
sequitur.
Totally
You were
sequitur in
claiming
this case.
you were claiming that you can do it though.
Not claiming, showing you can do it. There's no way you can
Show
put a
show it.
satellite into orbit without knowing the Earth is a sphere, without knowing orbital mechanics.
Okay, so
You think they
well
just
you
launch the
claimed
shit
you
off?
cl-
You think they just launch them off and think the Earth is flat?
you're You're moving the goalpost. So you claimed that you can't put satellites up without knowing the Earth's moving.
That's without the Earth as being a sphere. Yeah, moving. That
No,
would
you
help
said
because
moving.
that's why you launch eastward. You launch eastward usually to save
Okay,
energy.
so no one cares. I mean, the
Oh,
universe
no
is
one cares
moving.
why you launch eastward? You should. It's also why you launch from as far south as you can. Why the guys in Guyana can launch more weight than the guys say in Kazakhstan.
Okay, so can you show us the math of the astronauts on the ISS and why they're weightless according to your spinning globe?
Can I show you the math? Yes, I can.
Yeah.
Will you
Go ahead.
understand it? No. Oh, you want me to
Yeah,
show you the math
I will
now?
understand.
You want me to show you the math right now?
That's another add-on. It's another
Just
No,
look
add-on.
it up
no,
and
what
drop
you
a
mean add-on?
screenshot of
He
the
wants me
math.
to show me the math right now?
3 strikes and
Go-
you're out. That's 2 strikes. One more and you're out of here.
What? That he's
Theoretically easily
asking me
show the
for
math.
math when he never shows it? Well, get
I
out
have
of
it
here.
right here. I have the math right here. I'm about to show you.
Oh, let me show you. Let me see some math.
Okay, no problem.
I'll have math for a second.
I got you, brother. Since you're not able to show the math, I'll show you the math. That debunks you. Please refrain from nuh-uh.
I'm here to watch you get waxed, NASA.
With
You're
math
getting
from
drug around by your short hairs. I know it.
with math from Witsit, right?
Yep, about to show you the math, brother. I don't know why the screenshot's not popping up on my thing. Sec. Yeah, you can't actually do the math to explain the astronauts on ISS being weightless in your system of mechanics without adding a centrifugal term. So moreover, F equals ma is the sum of all real forces of an object. In his textbook Classical Mechanics, referring to F equals ma, John Taylor writes, where, as usual, F denotes the sum of all forces as identified in any inertial frame. So in the ISS orbiting Earth scenario, F equals ma must be extended by adding a term to the left side representing the centrifugal force. The math establishing the weightlessness of the orbiting crew is then this equation right here that literally adds a centrifugal value, right? F plus F equals, or F plus FCF, which is the centrifugal force, equals AM. You actually can't even use your equations of Newtonian gravity in your like rotating Earth model to explain the weightlessness of the orbital crew. You have to add a variable of centrifugal forces to the left side of the equation to be able to do it. Because you need to get to zero, bro. You know? Weightlessness, zero.
Yeah, when centrifugal force equals centripetal force, then you're at a net zero of gravitation, and that occurs at the radius of the ISS at the 17,000 miles an hour. So it's a simple centrifugal force calculation countered by the centripetal force of gravity equaling zero.
Do you not know the problem, though?
What's the problem?
Your system your system of mechanics doesn't have the real inertial forces. Newtonian mechanics doesn't have real inertial forces. He writes about this extensively. As well now.
Centrifugal force and gravitation are, very, very normal stuff. Centrifugal force, centripetal force. Yeah, I don't know what you're bringing in inertial forces.
That's what a centrifugal force is.
Well, good luck with that. We do have orbiting satellites orbiting over the poles, both poles. The fact there is a South Pole. You got within a hair's breadth of the South Pole on your trip. And now I don't know how on the planet with the South Pole and North Pole, satellites orbiting in polar orbit from North to South Pole every 45 minutes, a full 90-minute orbital. And I mean, Starlink Starlink has 15 or 1400 satellites at 97 degree inclination. I mean,
How
it's
does that help you?
ubiquitous. It's ubiquitous in our technology today.
Okay, so you just completely deflected and obfuscated away from the fact that you don't have real inertial forces in your mechanical system. That's okay, but
Oh yeah, okay, never
uh,
mind. Yeah.
yeah, so you can't answer that. That's okay. I mean, don't worry, no one can because your system just calls them fictitious and adds them anyway, even though they're external to your mechanical system. So it's okay.
Fictitious doesn't mean fake. Sorry,
What does it mean?
that means you know,
It means a
emergent.
net force. It's a net force.
Emergent.
It's not.
When you
It's not a fundamental force. It's a net of the fundamental forces.
caused by inertia. It's like when you take your car and you make a sharp turn, that pull
Caused
to the
by
outside.
inertia.
When you take your car and make a sharp turn, that pull to the outside, that's a fictitious force. But it's a very, you can feel it. You could get work done on it. But it's still a emergent force. You know, when you guys say fictitious, you think fictitious means fake. It's no.
No, it's a pseudo force.
Pseudo
There's
force.
no
Correct.
interaction
Emergent.
behind it, and
No, no, no.
there's no physical source.
Reference. You're correct. It's reference frame dependent. It's emergent in the reference frame. Thank you.
Right, it's a
Okay, so you
pseudo
don't.
force.
Yeah, you don't understand it. So your
I don't
model, your
understand it. I don't
no,
understand it. I basically told
no.
you what happens, and all you can say is "nuh-uh."
That's not all I said. You cut me off like always, right? So you don't understand it. But the point is that it's not like an actual physical force. It's a mathematical adjustment needed to make Newton's laws work from a
But it's
non-inertial
real.
accelerative
You
frame.
can feel it when you take your car and you
Wait,
make a
wait.
sharp corner. That force to the outside is you can feel it. It
That
is
supports
there.
our point.
Oh my
What do you
god,
mean?
dude, this guy.
It's a real.
That's what
Yo,
It
our
you can
point is.
feel it. What do you mean
Master
your
Phil,
point?
you shouldn't be feeling any forces in zero G's, dumb fuck.
No, we're not talking about zero G right now. In fact, we're talking about the difference between a emergent and a real force. Is just because it's a pseudo fictitious force doesn't mean it's fake,
Okay, bro. Like you guys say that, you love to
bro.
repeat that talking point,
It's not a
but
talking point,
you don't get, bruh. It's just a mathematical
bruh.
adjustment. It's just a mathematical
But it's a.
adjustment.
Can you feel that? Is your body physically thrown to the outside of the course of the
Yeah,
turn?
that's a your model problem.
Oh, but it happens. Right, right.
Yes,
It really.
because we don't live on your model because your model is
Don't live on your
ridiculous.
model. Model's ridiculous. Right, right. Because it actually happens, therefore it's ridiculous. Got it,
That's the point, bro. Like, dude,
bro.
okay, here. Let me
Dude,
read this for you. Maybe you'll understand.
who read what
All
from
right,
whom?
I got you. Check this out. So,
What are you reading?
wait, it's loading. It's
You use
loading.
your own words, or you have to use read.
I think I wrote this, yeah. But I put some quotes in
What
here.
you wrote this? Yeah.
Yeah.
Well, the
But I
last thing you
mean,
posted was pretty much fake, but that's okay.
that's cool. It's cited. So Newton's system, typically touted as a system that solved the question left over by Kepler of how a planet can orbit around the sun, in fact cannot answer this question unless additional forces that are not part of his mechanical system are incorporated. Thus, Newton's system fails to explain how even the solar system operates. Yeah, this problem has been hidden by simply labeling the additional forces fictitious or pseudo forces as if they just appear by themselves without a concrete source. Do you have a rebuttal?
You muted me. I'm sorry. Am I muted now?
Yeah, please don't
Yeah.
do cackle interruptions. When
I'm
someone's
sorry.
speaking, please
That
don't.
was funnier. This is funny as hell. I apologize for laughing at it.
Yeah,
We know
listen
all
to it.
about Newton's forces. We send satellites around the Earth. We send probes to different planets send probes to the sun, all using Newton's forces. So,
Okay, so can you rebut it
well,
though?
now you're
Like,
laughing. Yeah.
yeah, sorry, yeah, it's just like
Yeah,
just we're crazy. Like,
you just said that we can't use Newton's forces in the solar system, yet we do quite well. Thank you very much.
no, what I said was you just invoke it without attributing it to a concrete source. Do you have a rebuttal?
A rebuttal, but you don't understand Newton?
Uh,
Yeah.
or do you disagree with Newton when he says that it doesn't exist in his system of mechanics?
If you don't understand what emergent forces are, that's not my problem. Sorry.
Emergent from what? What concrete source?
In the reference frame.
So no concrete source.
Oh, so you're denying now that the force to the outside when you make a sharp turn, you're denying that you can feel that force.
No, I am absolutely not doing that. I'm specifically invoking that and the realness of that force to refute your entire model.
Oh, so what are you going to put in its place then?
I don't need to put anything in its place to falsify
Oh, you don't need to
it.
put anything in its place to falsify it, right? Despite the fact that when did Newton live? Was 400 years ago now, and it still works pretty well. But
It literally doesn't work.
Here comes Witsit, who's smarter than Newton. How come you're not like getting
That's why they need wires. They need
Nobel Prize?
wires because it's not really there. That's why they need wires to fake it.
Right. So that's going to be your Nobel Prize winning debunk Newton thing. They need wires in the ISS.
Nasty Shield, do you think if somebody was on the fence right now and they heard your response, do you think they would think that you have a strong point right now?
To Witsit? No, there's no strong point.
Anything you've responded with in the last 5 to 10 minutes. Yeah, anything.
I don't care. I really don't care. None of you guys are ever going to change your mind. I'm just here to laugh. Sorry.
Okay, so you're only here to laugh. You're not here to actually debate or give any actual rebuttals?
There is no debate here. Newton is well understood. The fact that Witsit doesn't understand it, not my problem. Sorry.
Okay, bro, you're not saying anything, but so
Yeah,
it doesn't
I
have a
am saying
concrete.
it.
I mean, we could easily replace it. Like, I could like
what?
Here, we could just do it like this. Like, I can take your model, flip it around, and that model is 1,000 times more viable than yours because it actually attributes a concrete source to the real inertial forces that you have to label as merely mathematical corrections that are pseudo or fictitious and don't have a concrete source. I asked you what the concrete source was, and you said reference frame.
Yeah, the reference frame dependent. That's correct.
Okay,
They're not
but
real forces.
what is the concrete source?
The concrete source?
Yeah, you agree for something to be real, it has to have a concrete source.
You have concrete sources for emergent forces. What's the concrete source for the turning force around when I turn my car? What's the concrete force for that? Concrete source for that force?
The actual acceleration of the car,
which is inertia, which is defined as in your world as pseudo force, right?
But wait, do you not get it though?
Well, you don't. I think you understand what a force is.
Brother.
Bro.
You don't have concrete forces. So if the Earth is in a central position, it's stationary. The angular momentum of a rotating universe would generate real inertial
How?
forces.
I asked you that yesterday, and you never told me how this actually does it. You know, well, how does the rotating sky do anything on Earth? Please tell me.
How does it do anything on Earth?
Yeah, how does the rotating sky influence, say, a Foucault pendulum?
Why are we deflecting? Why are you
Not deflecting.
obfuscating?
We're not obfuscating. I asked you this yesterday and you danced away from it. Then right now you
That's
just
not
went
true.
back to the rotating sky, the rotating universe causing this to happen, and I don't want to know how.
No, he asked you about the rotating Earth, and you deflected to something else.
I want to know how the rotating Earth, how the rotating universe, the rotating sky
He's
influences
asking
the
you
Foucault
about the
pendulum.
Earth. He's asking you about your model.
He says you
And
went right
since you
to the
don't,
rotating sky on the non-rotating flat Earth. How does the rotating sky influence Foucault's pendulum? Please.
he asked you about your rotating Earth,
So you're
and
not going to tell
you
me.
explain why those forces are not actually there. And you're deflecting away from that,
No,
which
he
shows
went
that
right
you
back
don't
to
have
the
an
rotating.
actual rebuttal to
Wait a
his
minute, hold on. I
question.
want to know. I'm asking for more information here. He danced away from it yesterday when we talked about the rotating sky, the rotating universe, and if the Earth is at the center, like he said, and the sky is rotating above it. He says that these forces would be translated to the Earth, and I want to know
Well,
how that
we're
occurs.
all here tonight, and he asked you about the rotating Earth, and you're
So,
deflecting off to something he allegedly said last night. So can you
no, he
stick to
allegedly
what we're
said it just
talking
10
about this
seconds
evening?
ago. 10 seconds ago, before he came and white knighted for him. Can he not answer his own questions?
Well, I'm
Okay,
just
so
trying
you
to
can't.
figure out what am I to
You,
believe, because NASA, you said like a minute ago.
So we're not going to
Hang on
answer
one
the
second,
question.
please.
Got it.
You said a minute ago that you're not here to learn anything. You're here to laugh at people and troll, etc. But now you're saying you want to learn about something.
Well,
So
you know,
which
you said
one
that I
do
should
I
learn about
believe?
something. So you said I wanted to learn about something. So here I am. I'm asking a question. I want to know how the rotating universe puts forces on the non-rotating Earth at the center of the universe.
You
So
do
just
know
as like a
Lemieux and transfer
as a
forces.
listener, which comment do I believe? The current one or the previous one?
Well, we
Give
could
us
go to that topic after, but the thing is, there was a question that was brought to you on the table. So how about if you'll respond in good faith to the one you were asked, and then maybe you could ask your question next.
Oh, maybe.
That's a good idea.
So we're not going to talk about how the rotating sky
Yeah,
influences.
we will. We're going to talk about that
Medium's
right after you
transfer
answer.
forces to objects is pretty. It's
Okay,
really
fine.
simple and basic.
I don't know. None. How about I answer your question?
Okay, thank you. Yeah, don't worry, brother. Don't feel alone. No one knows in your paradigm because there's no explanation. It's intrinsically
So
contradictory. You don't
how
have a
does the
concrete
rotating
source. It's a
sky?
mathematical correction.
So how does the
So
rotating sky
there
influence
are
the
many.
the
Look,
fact?
there are many possible mechanisms for this. We can just start with like your own paradigm, right? So if we use your current paradigm of relativity, there's something called lens Thirring effect, which is frame dragging of space time. This is your own paradigm. So if there's a rotating sphere, like hollow shell, the universe rotating around the Earth, then based on the Machian principle and the equivalence principle, relativity dictates that you would in fact have frame dragging. It's called the lens Thirring effect,
Frame
and
dragging,
this
yeah, the
would
rotating space time, right?
calm down. This would result in all the effects in your paradigm of even
So,
like flattening of the poles, the oblate nature of the Earth, the pendulum dragging, etc. Next,
so space time is oh no, no, stop one at a time, one at a time. So frame dragging means that space time is warping. So now you're invoking space time.
Well, that's why I said at least 4 times that it's your paradigm, and it just shows that you don't even
So
understand your own paradigm.
you're invoking space time now. Thank you.
No, no, only to elucidate the point that you don't understand that if your model is true, you have to concede that if the Earth was stationary and the universe is rotating around it, that the pendulum would be sufficiently explained. Would you like to concede that?
No, no, you're not going to. How does it? So this lens swing, but it does one way in the northern hemisphere and the other way in the southern hemisphere. So this lens Thirring effect is pretty specific, huh, for latitude. Interesting.
Okay, so you don't. Well, that would be dynamically equivalent.
Dynamically equivalent means you don't have an explanation for it.
Okay, so you don't understand it. It's okay, but like
I
anyway,
don't
Einstein
understand it. I don't
himself.
think you understand it.
Einstein himself admitted this, right? Like Mach came
Einstein did
around. He's
what?
like, that this has to be true if he even is able to propose relativity as possibly true.
So twist the fabric of the local space time. Okay, so now you're invoking space time. Thank you.
Okay, well, obviously I reject all that, but just to show you that your
Then
own
why did
paradigm
you invoke
admits it,
it? If you rejected,
because
why did you invoke it?
to make it's a hostile witness to make the
Hostile
point
witness
that
means
within
cherry pick. Hostile
that's not what
witness.
that means.
When you say heresy, yes, it is. When you invoke hostile witness, this means I just cherry pick something, and I
No,
don't
it's not.
want to. Yeah, that's exactly what it does.
Cherry picked means that if left in context, it would actually contradict what I claim about it. Can you
And this
elucidate how
is
that's the case? Or
yeah. This is cherry picking Einstein.
Einstein made it very clear. He wrote a letter to Mach himself in
Right,
1913 saying,
which you misunderstand, right?
"Have you read it?
Yeah, several times.
What is there to misunderstand about it? It's very point blank. He says that it would
All right.
drag the pendulum in the letter."
It says it dragged the Foucault pendulum in the letter.
Yeah. Yes. Einstein literally says that in the letter.
You read it, right, NASA Shill?
Oh, I'm sure. I don't remember.
Multiple
I don't remember
times.
this part of it.
All right. So anyway, so we can move on to another one. Another explanation we have is like Andre Assis. He writes relational mechanics. He's proposing a
Oh
different
God, Andreas
mechanical
Thies again.
system. So he
Andreas
explains
Thies,
like
yeah. Andreas Thies.
stop
So he
interrupting
went
me.
from Einstein.
Can you
Wait,
stop
hold on.
interrupting?
He's like, so he went from Einstein, who's like, one of the best known, most tested physicists like ever. Now we go to Andreas Thies, who's like some guy who wrote a couple books and nobody ever can verify what he says, right? Who's next? Are we going to pop off next?
Okay, so you could have waited till he was finished with the point. Other people would like to hear the point. Could you do that next time? Dude, like, we ask you this every day. Like, I don't know. Should we just not let you be here, or do you just have to disrupt the conversation every single day? Anyways, Witsit, could you finish your point? Because I think people want to hear that.
Yeah, so like what Andreas Cease basically says is he introduces a new mechanical system, and he says like the thing with Newton and Einstein is they're both making all these claims about space, but we'll throw out what Newton said about space, that it's absolute and fixed. We'll throw out what Einstein said about space, that it's relative and that it's 4D space geometry that bends and warps. He's like, space is just a concept. It doesn't matter. Throw it all out. That just the fact that there are physical objects, they're going to act on each other. They're going to create real forces in a real mechanical system. You don't need to attribute any properties to space. And what he shows is both Newtonian and Einsteinian dynamics generates an equivalence, a dynamic equivalence to explain the flattening of the poles and the pendulum. Those are the two phenomena he specifically invokes to explain it. He shows all the math of it. And interestingly enough, when it comes out, it's the equation for a rotating universe around a stationary Earth that would drag the pendulum. It is equivalent, like exactly equivalent to the electrodynamic force that is expressed by Weber's equations. So a relational electrodynamic force generated by the rotating universe and the distant bodies and galaxies and masses would also drag the pendulum. This has to be conceded by your own paradigm as well. Another one that I found today when I'm making my next presentation. This is Dennis Schema, Physical Foundations of General Relativity. I'll just go ahead and give you a heads up. You definitely don't want to try and discredit this guy. Anyway, in the rest frame of the particle, however, Newton's law of motion only holds if we introduce a fictitious centrifugal force field. Equation 10 shows that in our theory, this field is not fictitious, but arises from the gravitational effect of a rotating universe in agreement with Mach's principle. Thus, in our theory, we can regard the Earth as stationary and a Foucault pendulum as pulled around by the gravomagnetic field of the rotating universe. And he shows all the math. And that's Dennis Schema, The Physical Foundations of General Relativity, 1961. And he's best known. He's a British cosmologist, best known for his work on general relativity, cosmology, and the large-scale structure of the universe, and it helped shape modern understanding of gravitation in the cosmos. Cool, man. There are multiple other explanations, of course. If you have an ether, if you actually do have a medium, an ether, an absolute background medium to measure against, and it has physical properties, then there would be a translation of motion through that medium. It would be akin to a whirlpool in water. Right. It would be like standing in the middle of a whirlpool and then being like, are you telling me you can fill the whirlpool? It's like, yeah, of course you can. Translation of motion to the medium. Rotating universe and ether would translate down to the Earth. There would be a slight distinction, though, which would be the net magnitude and the consistency. And what do you know? That's exactly how pendulums work in real life. Super inconsistent. The effect is typically very small. And it doesn't actually match the prediction of your model at all. There's a few examples for you.
All right, so NASA Shield, do you think you'd be able to steel man that next time you ask the question in full?
No, I can't steel man that.
No. I gotcha. But do you have a response?
Yeah. I hold on a second. I need to go get some ranch dressing. That was a very good word salad. But
so an ad hominem fallacy.
Not ad hominem. you just spurred on about three or four
quoting
guys.
Physicists, bro.
Not one physicist, perhaps.
No, I quoted three physicists.
No, the other two guys were not. The Schema guy looks like he might have Schema.
Yeah, Schema.
Yeah, he actually might have to look into him. The other guys were basically, I mean, not
Einstein?
quite. Not Einstein. Einstein was a bona fide genius.
Well, he agrees with what I said. I cited him first.
He did, but yeah, I know. You cherry picked him. You cherry picked one part of him without the other parts. Got it.
The whole entire letter is about how Mach was right and he was wrong, and that a rotating universe would
rotating space time. Thank you for invoking space-time.
Well, that's Einstein's theory. That's his version of it, which is where you then get Lenz's Thirring effect, which is from Hans Thirring, right? But that's just a specific relativistic application of the Machian principle. The principle itself holds true regardless of what system of dynamics you apply to it. This gets worse and worse and worse for you, by the way.
It's worse and worse and worse as you like go further and further down the rabbit hole. Yeah, I know.
Yeah, just the more you research it, the worse it gets for the heliocentric model.
That's incorrect, but nice try. It does for you because you pick guys that are out there and then
what
you cherry pick. You'll cherry pick
Albert Einstein, Stephen Hawking, Wolfgang Pauli. I'm just going to read the people I have quotes of: Hans Reichenbach, Sir Hermann Bondi, Max Born. Hey, is Max Born a quackpot?
Do you think that Stephen Hawking thought the Earth was flat and at the center of the universe?
James Jeans, Sir
You
Karl
think Einstein
Popper.
thought that the Earth was flat and at the center of the universe?
Wait, I'm just going through the list of people that all say the Earth can be stationary.
Do you think Wolfgang
Sir
Pauli
Oliver
thought the Earth
Lodge.
was stationary and at the
These
Earth?
are some of the most
at the center of
famous
the universe?
physicists in the world, bro.
Do you think that they all thought that the Earth was flat, and stationary, and at the center of the universe?
A lot of them seem to think the Earth was in the center of the universe. Yeah.
I would like to see any of them say that.
Well, they're not going to say it explicitly. They say it for people that can understand what they're saying. I mean, like, it would be stupid for them to just say Earth is.
Then show it to me in language that says basically that the Earth is flat.
Hey, check it. If someone says, so the implications of this test, if it doesn't detect motion, would be that the Earth is stationary at rest in the center of the universe. And despite repeated attempts, I've finally come to the conclusion to reluctantly concede that it, in fact, is impossible to detect that motion. What is he saying?
He's rejecting that assumption. Yeah, I understand.
No,
because
he's literally just saying, like, look,
there are other tests. There are other tests that show that that this is a possible solution to it, but we'll reject that because it's like like a negative number or something. You understand that all squared functions have like positive and negative things, and only one of them makes sense physically.
Physically, no. Whether we say the Earth rotates or the universe revolves around it, the physical content of both statements is identical. The choice of a coordinate system has no impact on the reality of the phenomena.
Again, you haven't told, except for like bendy space time now, which apparently I thought you rejected, but now you're using to explain. That's interesting.
Strawman.
You want it both ways.
Strawman.
Strawman? No, you just invoked it. Did you not? Are you saying you didn't invoke it now?
I didn't invoke it as true. I invoked it to show that in your own paradigm, you have to concede it's possible.
I don't have to concede anything to you.
Well, then you got to reject relativity, which is fine with me.
You just invoked relativity. You just invoked part of Einstein. So now you want me to reject all relativity, but you won't. But you invoke Einstein, only part of Einstein with bendy space-time, twisting space-time in this case.
Okay, you're just being dishonest.
I'm being dishonest. These are your quotes, not mine.
You're just being bad faith.
I'm in bad faith, right?
Yeah, because I didn't actually. I didn't claim it.
You didn't claim it.
You asked him how it could work, and he laid out several different ways. That's
right.
Different.
One of which was Einstein invoking space-time.
Yes, and I made it clear I reject space-time altogether. So why do you keep saying I invoked it?
And why'd you bring it up? As a
Can you not answer that? Can you still man my answer to that?
No, I can't steel man anything you do, Witsit. I really can't. I try, but I can't.
That's the problem. That's the problem.
I can't think the way you think because you religiously assume that the Earth is stationary and at the center of the universe.
No, steel manning doesn't mean you have to agree with it. It just means that you have to be able to understand it enough to give the best version of what's being said.
I can't think like he does. I can't make the leaps of faith he makes. You're not coherent. No, you're incoherent at best.
So you can't even understand my position. So you obviously couldn't know I was wrong.
Well, I know you're wrong because you're invoking stuff that you don't understand, and
I don't understand it.
You invoked space time, and then say that you didn't reject space time. You invoked
Oh my god,
Einstein.
it's so bad.
You invoked Einstein and then said, "Nuh-uh." I mean,
That's such a so low level, dude. You can do better
it
than
is
that,
low
man.
level. It is low level because you invoked Einstein and then I I come and ask you about it and you say, "Oh no, I reject that." But yet you invoked it.
Listen. I am critiquing. It's an internal critique. I'm critiquing your position, your belief,
No, that's not my
and
belief nor my position. Sorry.
it has to be.
No, incorrect.
So then you reject relativity.
I reject relativity? Right.
Yeah.
See, the thing about it is that you said that it will explain how a rotating sky influences the focal pendulum, and that's not even
Yep.
what anybody thinks how the focal pendulum works. It's not the
Well,
rotating
Einstein made
sky
it clear.
above.
Einstein made
Einstein
it
made it
clear
clear.
that if relativity is true, that a rotating universe around a stationary Earth would make the pendulum drag. Do you understand?
You think that Einstein thought that the Earth was at the center of the universe and not
Doesn't matter what
rotating?
he thought.
Oh, got it. Right. Of course not.
Einstein thought that Japanese people were equivalent to dogs. Why do I
Wow,
care?
that has something to do with what we're talking about.
Do you not understand the point? Is that it doesn't have anything to do with it. What he
No,
thought and
that's physics.
believed has nothing to do with it.
We're talking physics now. We're not talking.
Yeah,
It's
you're invoking his system of physics while simultaneously claiming that he was wrong about it.
I'm claiming he was wrong about it.
Yes.
So NASA Shill, why would you deny Einstein's understanding of the equivalence of one thing turning and then the other thing turning and vice versa, right? That the forces would be the same. Why would you think that logically that would not follow?
You serious? You think that Einstein thought that the Earth
Why don't
was
you
not?
ever answer a question? I feel like every time you come in here, it's like a my dad could beat up your dad and then a nuh-uh conversation. Every time.
So don't blame me
Nuh-uh.
about saying
My dad can beat
no.
up your dad. Nuh-uh.
This is. I mean, no is the flat Earth fallback position to everything.
Then why do you use it all the time and none of us do? But can you answer my question?
Well, I mean, no is the proper response to some when you just go off
When
the
I
wall.
asked you, why wouldn't you be able to understand the logic of the inverse being correct? Meaning, if the Earth is moving through a bending and warping spacetime, that you would have certain effects. And if the universe was moving around a stationary Earth, you would have the same effects, right? There's an equivalence there. Do you think that that logic follows?
Well, you said the word if. So why don't you start off with once upon a
Can
time
you
in a
answer a
galaxy?
fucking question, dude?
Well, no.
Ever?
If you're gonna have me answer if questions, I want you to start off once upon a time in a galaxy far, far away.
Science is nothing but answering if questions. Do you not like science? Do you not believe
I
in
love
science?
science.
Do you
What's your
not
background in science?
using science or logic?
What's your background in science?
How about you answer my question
How
first?
about you tell me your background in science so I know what level to talk to you on?
Oh my god.
Dude.
You're not even trying. Like, dude, think about
Maybe
it.
you
You
should
can't
just
even answer that
mute this guy
simple of
and
a
move
question.
on. Like,
Yeah, probably.
It's a bad faith bonanza. Like, I don't want to get all personally attacky, but no, NASA Shield, you are truly okay, it's going to sound like a personal attack, but I don't know if anyone could be in more bad faith. Like, everything you say is either an ad hom, a derail, a non sequitur. Do you realize that that's the case, or like, do you think you're debating in good faith at all?
Oh no, I'm debating flat earthers. So no, this is nothing is in good faith here because I don't think Witsit in good faith either. To tell you the truth, I don't think any argument you ever say is in good faith.
well, then maybe we can just mute you and move on if you admit
There
that
you go.
you are never going to have a good faith conversation.
With flat earthers, it's really difficult because you guys are
And why
not
are you
good.
even here, bro?
I told you before. I can't believe that it's 2026 and I actually have people using Einstein to explain that the Earth is flat and unrotated at the center of the universe.
Well, I can't believe, based on all the interactions I've had with you, that you can even tie your shoes.
Well, you'd be incorrect on that. My shoes are well tied. Thank you. Mom taught me
Velcro
that.
doesn't count, but either way, like,
I don't have Velcro.
it's ridiculous.
No.
Yeah. I'll be honest. I think that deep down that like we're right about things.
No, you're not. You're rarely right about anything.
It comes off that way. Like the level of this guy, again, it's gonna sound like a personal type, but you have like a scattered insecurity going on where yeah. And it kind of causes you not to be able to have like a calm, rational conversation because you'll just instantly kind of go off into either an ad hom or an interruption or like you've been doing. Or you'll just start asking people about their credentials in the middle of a conversation that has nothing to do with that.
I mean, I need to know what. Yeah, I don't know. This is really interesting to me that everyone here is so into science. I don't think anybody has taken science beyond high school.
Yeah, but dude, if you really thought that and you were here, you could be in good faith and you could just be calmly educating people like a wise elder.
No,
that's what you think you can do, and you could just share the information because there's various people listening, other than the person you're debating, that would be able to hear your point, whatever it is.
I've tried that in the past and it's just rejected.
All right. Well, it's kind of like turning into an intervention. It's like the NASA shill intervention.
Well, you can think all you want, but no.
All right.
I mean, you laugh and giggle. Yeah, that's good. Always good.
Yeah.
He's traumatized.
I'm traumatized. Right.
But like, so if you were to discover that the Earth actually were stationary, like in the center of the universe, would that like really mess with you or something?
What would be the test for that, Witsit?
I'm just wondering, like, would that like really mess with you?
Well, I mean, you have a nice hypothesis. How are you going to prove your hypothesis?
Would that really mess with you?
You have a hypothesis. Do you have a test for the hypothesis?
No, I'm not. So let's just pretend I believe there was a spinning, tilted, wobbling globe falling through space or whatever. Like, I'm asking about you. If you, after all this time you've invested, for example, if you were to hypothetically discover that actually turns out the Earth was stationary in the center of the universe.
So if you ask me a hypothetical question, you have to start off, once upon a time in a galaxy far, far away.
Okay, once upon a time in a galaxy far, far away, you found out that after 10 years of obsessively and sadistically trying to mock people that were ironically more informed than you, you finally had the realization and discovery that, in fact, the Earth was stationary in the center of the universe. Would that, like, mess with you?
What test would I want to find that?
Doesn't matter.
Oh, it doesn't matter. Right.
Say that the mainstream academia came out with a brand new discovery from one of our space probes, and they found out that there was irrefutable evidence that everything was moving around the Earth. And actually, prior to this, we thought that the Earth was moving. That's before we came across this new groundbreaking information.
Well, let's look at it the other way, because right now everything is the other way around. I mean, and you're the one. In reality, we've shown that the Earth is a planet. We've shown that it goes around the sun. The sun goes around the Milky Way. The Milky Way is attracted to others. We've shown all this stuff, and you say no, it must be flat.
You haven't shown any of that stuff.
Yes, we have. Yeah, that's pretty much all shown.
All right, bro. I don't think you can do it.
So you want me to pretend that all this is false and pretend that tomorrow we're going to just disprove it all. In the meantime, though, all this is proven, and all you can say is my book says so, and therefore everything that we know must be false.
Nope, nothing to do with the book.
No, it has to do with the book.
No, but can you answer how would it affect you?
I don't play Witsit's hypotheticals, because what's happening is he's denying reality, and tomorrow he says that all of reality suddenly flips so that he's right. How would I feel? I'd probably feel much like you. I'd be confused and try to come up with some crackpot like Ken Wheeler to explain how it all works.
You would become a crackpot if you found out the Earth was in the center of the universe?
Well, if everything were reversed and suddenly tomorrow everything you say is true and everything I know is false, in this bizarro world, I would probably feel like you and would have to go reject it all and say, oh no, all that's false. I'm going to cling to these crackpot scientists who think that it's the other way. That's what
Would you
you're
become
doing.
a creationist?
Creationist is a different story. We're talking about
Would you
the
become a creationist?
creationist is a different story. We were talking about something else.
Well,
But
no, I'm
anyway,
saying it's like an implication though.
so I mean, that if the again, then we would be reversed, right? You'd be the one with all the facts, and I would be the one on YouTube with a few of my buddies and coming up with crackpots that I can find.
You know, my favorite question, Witsit, you talked about a lot of great ideas tonight. And we all know there's different flat earth maps and setups, 1 pole, 2 poles, whatever. Let's say the earth is planar and stationary, just for honesty's sake, for this convo. Does these different setups ultimately matter to the things that you're talking about? Any of them? You said a lot. I'll let you pick. Like, does it ultimately matter which one, or is it just the planar plus stationary? Any? We don't even need to like get to the specifics. Like, you see what I'm asking?
I mean, I think it matters in terms of better understanding. You know what I mean? But like, I think that the major implications are there regardless, right?
Thank you very much.
Mhm.
That's all I have.
I mean, obviously, like whatever the true nature of the Earth is, if we were to figure it out, that would be a huge deal for sure. Make the people much more powerful.
Well, NASA show left, so.
And NASA show would be a creationist. Most likely.
Yo, I only asked that because I'm just like, I think that that would be rough for him, right? Like, because I genuinely just don't and have never interpreted like the Antarctica thing as a debunk of flat Earth, but that was like as close as I've been in a while, being able to like really look at that possibility. And yeah, I mean there was a part of me that was like, damn, if that's the case, then I would have like wasted a good amount of time. But at the same time, I wouldn't really feel like I did, right? Because um we've like undeniably debunked so much of mainstream physics. It's just it's indisputable, regardless if I was wrong about any specific conclusions. And then I just honestly don't think that's the case, right? I mean, it would benefit me greatly to have flipped, like financially,
What's
but
the reason?
you know,
What's the reason? What's the reasoning why you think you didn't debunk flat Earth in Antarctica?
it's inconsequential to the shape of the Earth.
No, it's you debunked. It was a debunk. It was a falsification of the robotomist model.
It's a debunk of like the AE map with the belief that we see the physical actual position of the sun.
Yeah, that's I'm attributing that to robot the robotomist model.
Sure. If he claims that we could see
Yeah,
the actual physical sun, then yeah, he's definitely wrong.
that's false. The trip to Antarctica falsified the flat Earth.
No.
Why not? That's what I'm asking you is what's the reasoning that you say that that's not the case?
We knew that on a flat Earth, the sun had to be in a apparent position before we went to Antarctica.
No, it's a logical consequence of the robotomist model that you can't have a 24-hour sun in Antarctica.
Why do you keep boxing flat? Why do you keep like equivocating the Robotham model and flat Earth?
Because it's just a shorthand. The robotomist model is the AE map with the sun traversing in a circle, a racetrack, if you will, around the equator. So if it's around the equator, it can't be south of Antarctica, can it?
No. No, but it could still do that same thing, and then there'd be an apparent position in Antarctica.
What's an apparent position?
What do you mean, what's an apparent position? You know, like whenever we
Yeah.
see, you know, like when we see the selenilian eclipse and the sun and the moon are both above the earth during the eclipse, despite you guys claiming that it's the sun, moon, and earth all lined up and that the earth is actually blocking the sun, but it's above the earth. And then you guys claim, oh, well, the sun just looks like it's above the horizon, but really it's not. It's just in an. Go ahead.
But that's not the prediction.
Wait, what?
That's not the prediction.
Wait, so you're saying that in the lunar eclipse, the globe Earth model doesn't predict that the sun goes down below the Earth?
No, I'm saying that in the final experiment, the
Oh my gosh.
prediction in the final experiment, the prediction is right that the sun will remain above the horizon for 24 hours. We saw the horizon. You saw it above the horizon for 24 hours, right?
You weren't following what was
Mm-hmm.
said about the eclipses, that during a selenilian eclipse, the globe model claims that it's in an apparent position, right? It's not actually
Yes.
there. It's okay.
Yes.
So,
Yes.
okay, good. We got through that. All right.
Yeah, that
So
has
you
nothing
do
to
know what
do.
an apparent position is. Well, you said you didn't know what one was.
That's a non sequitur. It's not related
No, it's not.
to the final
It
experiment.
is related. You said
How
what's
so?
an apparent, but you said what's an apparent position.
Yes.
I gave you an
What is?
example from your own paradigm. It's not
Yes.
non sequitur. Please stop misusing phrases you don't understand.
No, I do understand them. It has nothing to do with why we saw a 24-hour sun in Antarctica. That's
No,
not
what it
due
has
to
to
an
do
apparent.
with is you claiming that you didn't know what apparent positions were.
I know what an apparent position is. I wanted you to
Why'd you
define it.
ask me what it was?
I wanted you to define it.
Okay, well, now we're on the same page, right?
Right. So it's due to refraction. That's why we see the sun above the horizon and the moon above the
Okay.
horizon during a selenilian eclipse. That has nothing to do with why we saw the sun south in Antarctica.
I would partially agree. I think refraction probably plays a role, but it's probably not the primary causal agent, but that's a different topic. But okay, yeah, so something's causing optical displacement of the sun. If the sun moves over top of a flat Earth, the fact that we saw what appeared to be the sun stay in the sky repeatedly, not just 24 hours. I mean, it just kept
You think
going.
it wasn't the sun? You think you said it appeared to be the
I
sun.
think
What
it
was
was an
it?
apparent. Well, I think it was an apparent position of the sun.
Oh, so can you calculate the refraction? Why was it up above the horizon for
I'm not
24
invoking
hours?
refraction.
That's what apparent means. Its
No,
apparent
no, it's not.
location is
No,
due
it's
to
not.
refraction. Oh, well, then what mechanism did make it appear above the horizon?
Well, there's a few different things that can do it, right? So, like just a reflective surface with dome optics can cause an apparent sun on the outer rim.
Oh, can you demonstrate that that was a reflection?
Can I demonstrate that it was one? No, I can't go. I can't go up in the sky where the sun is.
So, MC Toon and the other Globers there showed you the sunspots. They showed you that they were not
Well,
reversed,
they didn't
and
show me anything. I was the
therefore,
first one to look at the sunspots.
and therefore, not a reflection because they were not reversed because
They didn't
reflection
show me anything.
reverses.
They didn't show me anything.
Did you see the sunspots?
Yeah, I was the first one to look
And
at them.
were they reflected?
They were inverted.
No, they were not inverted.
Yes, they were.
No, they were not They were not reversed in a mirror
They were
reflection. They were not
inverted.
reversed. They were not.
They were
Yes,
inverted.
because you're in the south. Because you're in the south, the way the moon is inverted, but they were not reversed.
Oh, you don't get it.
They were not reversed. It
Wait,
was
why would
not a
they be?
reflection.
Wait, you don't get it though. Like, you understand that if a mirror can take something from the right and then move it to the left, if you reposition the mirror, it can take something from the top and put it at the bottom.
Can you show that there was a mirror?
Just
Where was the
did
mirror?
you not know that it could make the top go to the
No.
bottom?
So the image was not reversed or flipped as it would be in a mirror. That is not the
Yeah, it
case.
was. It was
You're
flipped
just
like it would be
lying.
in a mirror.
No,
It was
you're
flipped. It was
lying.
flipped.
You're
No, I'm not.
lying.
No, I'm not.
You're lying. It was shown to be identical by people in the northern hemisphere who took pictures of the sunspots at the same time.
Yeah, that's what we would
So
predict.
you're just lying.
That's what we would predict.
No, they were not reversed.
They were flipped.
It was not a mirror image.
It was flipped.
Right, because you're in the southern hemisphere, but they were not reversed. Stop
But
lying.
do you understand that if I take a mirror and it reflects, it like inverts it from right to left. If I moved that mirror, it would move from top to bottom.
Yeah, they were not reversed.
Why would they have to be reversed?
I never heard him
That's
say
how
the word
mirrors.
reversed. I never
That's
heard.
how mirrors work. Right. The
Wait,
the evidence shows that the sunspots on the sun were not the result of a mirror image, because people in the northern hemisphere took images of the sunspots at the same time,
You think I don't
showing
know that? I'm the one that set it up.
showing that it was not a mirror image.
You realize I'm
You
the one
keep
that set that up, right?
you keep lying,
So why are
trying
you
to say it
teaching me
was
about it?
flipped, right? That's not
Wait, but
reversed.
Brenda, did you know that I'm the one that set that up?
I don't
So
care who
I'm the
set it up.
one that looked. You guys, after a whole year of preparation, didn't even put together what the best exclusive quote unquote evidence could have been for you. The crazy flat earther had to do it for you. And the reason I did that is because I just actually am trying to figure out the truth. And I knew that a bunch of the stuff that you guys were doing, like measuring distances between longitudes, were stupid and meant nothing. So I went and looked at something that actually was somewhat significant. And I set up a bunch of people in northern latitude. I told a bunch of people going that we should reach out to people about the corresponding northern latitude, and then made sure that we looked at the sunspots at the same time, because your side didn't even think about doing that.
And if you're interested in the truth, why are you lying?
What am I lying about?
You said that it was flipped as a response to whether it was a mirror image. You know that's different. That's not the same.
No, what? Hanvy's replicated it.
Being flipped is not the same as a mirror
Hanvy
image.
replicated it.
Right. So why are you lying?
Hanvy physically replicated it.
In a mirror image?
Yeah.
No.
Yes. Joe Hanvy replicated it. I mean, he's replicated a lot of things. He replicated the star trails, then the star trails on the equator, and then into the south. He's replicated the different colors of the eclipses and the eclipses themselves. He's replicated the sun exactly as we see them locally with clouds on Earth, replicated sun pillars, replicated the 24-hour sun, replicated it going in the counter rotation, replicated the flip of the sunspots, replicated the moon doing it as well, replicated rainbows. He's replicated many different things, replicated galaxies, replicated nebulas, replicated all these things. I mean, way more than you guys can replicate. You can't replicate any of the stuff that you believe.
We can consistently model and predict. Joe Hanvey hasn't replicated anything. He has a
That's just
salad.
a lie.
He has a salad bowl.
That's what you think, that like just calling it a salad bowl somehow changed the
Yeah.
fact that the physical demonstration and proof of concept?
Yeah, it doesn't prove anything because he takes images from outside of the salad bowl of reflections on the inside of the salad bowl, not from the camera inside of it, and he doesn't
Wrong.
reproduce, and he
Wrong.
can't make predictions based on his model.
Wrong.
He doesn't have a model.
Wrong. He
That's a
takes them
salad
from
bowl.
outside. He takes them from outside and inside, and he puts a light source outside and inside. He uses a collimated and diffused light source to do all of them. Try
Yeah,
them.
so which is it? Which is it? Is the light source inside or outside of the salad bowl?
Both.
Yeah, so where's the sun? Is it inside or outside of the firmament?
Both.
So that's a contradiction, and
No,
that
it's not.
falsifies your claim. Something
Nope.
can't be both inside and outside at the same time. So
Nope.
that's a
It's
falsification.
there are layers.
Layers.
Yeah.
So how
So
can
it's
the sun be
outside the
inside?
lowest layer, but it's inside the higher
So how
layers.
can the sun be inside and outside of the firmament?
I just addressed you.
No, you didn't. You said layers. That doesn't
There
address
are
it.
layers. It's outside the lower layer, but inside the higher layers. It's inside the firmament, which has
Right. So
layers.
it can't be inside and outside at the same time.
It has layers. Do you not understand what I'm saying to you? Imagine your salad bowl, but imagine layering 7 of them, and they just get slightly bigger each time. And then within one of those layers, you place the sun. Then from inside on the earth, it would be outside the salad bowl. That was the smallest and closest to you. But inside the slightly bigger salad bowls that layered above it, it would be both outside of the dome but inside of the other domes.
So this is just an ad hoc rationalization. He doesn't use 7 salad bowls. He uses one, and from which he shows the light
Doesn't matter.
from the inside and the outside. It does matter because it entails a contradiction. Contradictions falsify the claim.
Nothing was contradictory.
Inside and outside is a contradiction.
But that's not what I'm claiming. It's a misrepresentation. It's just a straw man.
No, but that's what he did. You're making an ad hoc
No.
rationalization.
No. I am speculating what I think it could be. I personally believe there are 7 layers to a dome.
Oh, so it's not Johannes' model then. Got it.
It doesn't matter because the proof of concept is demonstrated both ways. He takes the light source from inside of a dome and shows the reflection and the apparent location. He takes the light source from outside of it and does the same thing. He takes the camera from inside
You're
and
right.
the camera from outside.
Yes, he does that, and he can't do that because that constitutes a contradiction, falsifying his
No,
claim.
it
Because
doesn't.
the light source cannot be both inside and outside.
No one's claiming that it is in the way that you're saying it is. He's
You
just
said it
proving that it
was.
doesn't.
You
I
said it
claim
was
that
in one layer and outside of another. You said
that's
that.
not a contradiction.
I know, but it's not his model.
That's right, but the reason that
That's
what the
right.
thing about his model that his model proves, right, that it would happen either way.
No, it doesn't.
It does.
No, it shows one way to make one explanation and another way to make another, but they can't both be true. Only
No, they can't both be
one.
true. No one's claiming that they're both true. No one's claiming
They
that when he
have
holds
to
it up.
both. They have to both be true because we have one sun and there is one singular phenomenon associated with the sun, not 2 separate suns with 2 separate source locations of the light.
No one claimed that there was 2 separate source locations.
You are when you place the light inside and outside, it's either a contradiction, falsifying the claim, or there are 2 suns.
That's incorrect. There's only one source, right? And then there's an apparent location.
Yeah, apparent isn't a magical word. Apparent just means visible. It's due to refraction.
No, that's not what it means.
So that's what apparent means. It means visible.
No, not in the context, right? Like you have actual and apparent locations. So
Yes. Yes.
So
When the
using
sun
like a
is
colloquial layman definition of a word is just goofy.
when the sun is below the horizon by about half a degree, it appears to be above the horizon due to her refraction.
That's what
That's
you
its
believe.
apparent location. No, that's what the
That's what you
word
believe.
apparent means. That's what the word apparent means. It means the
No.
sun appears to be, is visible as in a different location than its actual location
Okay,
due
thanks.
to refraction. Just like a
It doesn't. No,
pencil,
the word
no,
apparent location is not exclusive to refraction.
just like a pencil in a glass of water, the part of the pencil that is in the water has an apparent position, right? That is different
Can we
than its
stop doing this thing
actual
where you pretend
position
you're teaching me basic concepts?
because
What are you doing?
Because of refraction.
Why are you talking to me like I don't understand basic concepts?
Due to long
It's
experience, it's
it's just this
obvious.
like projection of intellectual insecurity you're projecting onto me, and you need to like come in here and like get your rocks off, acting like you're talking down to me and so much smarter than me or something. Like I'm not participating in that, so you can cut it out or just
I don't
disengage.
think I'm that smart. I think I'm
You,
average. I think I'm average.
okay. Well, the last thing I need is someone that's average intellect to teach me that a pencil looks different in water.
But I'm teaching you about apparent versus actual.
I
The
don't need you
apparent
to teach me anything about that.
That's what apparent means. It means the pencil is visibly broken because of refraction.
Why
Right?
do you keep doing
Right?
it? Yes.
Yes, to teach you about what apparent
Why
means.
would I need you to
The
teach me? I
sun,
already know.
no, apparently you don't, because you don't understand,
Mm,
right, that
doesn't follow.
the sun's apparent position is not its actual position, and it's due to refraction.
Okay. So if I take a flashlight and I shine it at a mirror, and then someone goes and looks at the mirror, and it looks like the flashlight is over there, is that an apparent position? Yes or no?
Yeah.
Okay, so it's not just refraction then.
So you think it's due to reflection?
I just answer my question. You just claimed it was only because of refraction, and that's what apparent means. You concede that you were wrong.
Yes, that's what people mean when they talk about celestial objects, and their apparent position versus their
I
actual
don't care what
position
people
is
mean.
due to celestial refraction.
You just claimed that it could only be caused by refraction. That's the only way you can have an apparent
Where's the
location. You
mirror?
admit that you were wrong. You admit you were
Where's
wrong, right?
Right? No, because we demonstrated that it can't be a mirror reflection, right? Because the image was not reversed. There is
It's
no
so interesting.
image.
It's like all of you do this. Like none of you can ever admit you were wrong about
You
something.
have to go meta because you can't respond, right?
No, I'm
Because you
just talking about how
know
you can't admit you
that
were wrong.
the apparent. So you need to produce the mirror. Where is this mirror?
Uh, there are multiple. The dome itself could cause a reflection. There
Where
could
is
be
this
a
dome?
medium
Produce the dome. Where is this
above it.
dome?
Produce your dark energy. Where's your dark energy?
Dark energy has nothing to do with the shape of the earth.
Do you understand though? Do you understand why I brought it up? You can't be a
Because
hypocrite. You're a
you're
hypocrite. You
desperately
believe in all kinds of stuff that you can't physically access, but then somehow expect to apply some double standard to flat earthers where if they can't physically access it, it can't exist.
no. You need to produce the dome. You
You
can't
need to
produce
produce
it.
dark energy. You need to produce dark energy.
No, I don't.
Okay, then you agree it can't exist.
No, the dark
Oh,
energy has nothing to do with the topic. It's a category error.
you don't understand?
Yes,
No,
I
you
do
do.
understand.
You're just bad faith. You're just bad faith.
No, it's not bad faith. You're bad faith. You're desperately
So
spinning ad
here,
hoc
maybe answer this
rationalization.
question. Maybe answer this question. Why is it permissible for you to invoke things that you cannot physically access, but not permissible for flat earthers to do it?
I'm not invoking dark energy. I'm invoking the globe.
No, but you do invoke dark energy and dark matter in general. So my question is, why is it permissible for you to invoke things that aren't physically accessible, but not for flat
Again,
earthers to do it?
again, I'm not invoking dark energy. Dark
All right, I'm not
energy
going to respond
has,
to you
of
anymore
course not.
until you answer
Thank
that
you.
question honestly. Yeah, you can't
I
answer
am.
it
I
because
am.
you're a bad faith actor.
Well, number one, dark energy is not something that is like there is a consensus on.
Okay, there's not a consensus on the dome either. Some flat earthers don't think there's a dome.
So
Some flat earthers think that it's
there is
super
consensus.
solid. Some flat earthers think it's multiple layers. Some flat earthers think that it's one layer.
There's a consensus on the globe, and you don't have a dome. Supposedly, flat earthers claim that they only believe in things they can see and touch. Nobody has ever seen nor
What?
touched the
What?
firmament.
Almost every flat
Flat
earther I
earthers,
know believes in God, and you can't see or touch God.
Flat earthers consistently claim that you only believe in things you can see or touch.
Not true.
Yes, they do. They claim
No.
that all the time.
No. No.
So you believe in things that you can't see or touch?
Of course.
Right, like
Like
atoms
my
and
mind and
electrons.
like my mind and consciousness and God and the metaphysical and intuition and dreams and thoughts,
Yeah. So
knowledge.
the problem is that you have no firmament, no mirror reflection, because your explanation is ad hoc.
No, it's not.
Yeah, it is. Ad hoc means something. You can look it up if you don't know what it
The
means.
necessary antecedent to gas pressure on Earth is physical containment.
There's no
That's not
such
ad
thing.
hoc.
What's it? In logic, there's no such thing as a necessary antecedent.
Well, you're wrong.
That's not logic.
You're wrong.
Prove it.
You prove that an antecedent is a real thing.
No, prove that there's such a thing as a necessary antecedent. What does the word antecedent mean?
Requirements.
What?
Requirements.
Would you like to guess again?
No.
Of course not, because you don't know what the word antecedent means. It's just a
It just
word
comes
that you
before the
parrot.
other thing. It's a prerequisite. It's a requirement.
Nope, that's not what antecedent
Yes.
means.
It means it
No, it
comes
does not.
before the other thing, like a prerequisite. What does prerequisite
No,
mean?
an antecedent is not a prerequisite.
Yes, it is.
No, it is not. You don't
So
know
you don't
even the
understand.
first thing about logic.
Okay, so you're literally trying to conflate the antecedent in a logical argument with the phrase necessary antecedent because you're in bad faith. But I think you
No,
actually maybe just don't even know that that's
I know the
fallacious.
difference between the antecedent and the
Equivocation
consequent.
fallacy. Equivocation
I know
fallacy.
the difference between an antecedent and a consequent. I know what those
Equivocation
mean.
fallacy.
You don't know. You don't know what they mean. These are just words that you parrot without any understanding.
Equivocation.
What is an equivocation fallacy?
What you just did.
What was that?
You equivocated two different things.
What does the word equivocation mean?
You
This will be
don't know what
another
it means?
logical.
Is this where
This will
is
be
this where you just like ask me a bunch of random questions?
to show and to demonstrate to everybody that you have no idea what you're talking
Oh
about.
my God. Okay.
You don't
Equivocation
know
is
what
where
antecedent.
stop. It's where you use one thing to mean two different things in the same argument.
There you go.
Duh, you just did that.
No, I didn't.
Yeah, you did. You equivocated the logical argument application of antecedent and then the colloquial term I just used, simply meaning
No, I
the
didn't.
require. Yeah, you did. When I said necessary antecedent, you tried to act like I didn't know what that meant. It's not a real thing. And you started bringing up an
You,
antecedent consequent relationship in a logical argument.
yeah, you don't know what those words mean. You have no
All
idea
right, so we're going to
that
move on.
what
This
a
is so
material,
low
what a
IQ at this
material
point.
implication. What is material implication?
What is low IQ?
What does necessary mean? You
What
said
is
necessary
what is a
antecedent.
waste of
What does
time?
necessary mean?
What does bad faith mean?
Run away.
No one's running away. I'm just annoyed.
Yes, you're because you can't
Yeah. Okay.
win.
Sounds good. Sounds
You
good.
can't.
So the
You don't.
fundamental difference in you and I is I'm able to actually understand and acknowledge the limitation of my knowledge because it requires an application of humility that you simply seem not to possess. You need to pretend like you understand things that you don't understand, while claiming that we need to give you like physical access to the dome or it's not real. You simultaneously believe to know that things are hundreds of light years away and that there's dark matter and dark energy and that inflatons existed at the Big Bang with pre-existing energy. We're not going to talk about that part. And then rocks turned into fish that jumped out of the water and then grew some feet and then grew into strawberries and that's my ancestors and blah 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 blah. You believe in all kinds of things that you don't have physical access to. You believe in all kinds of things you can't empirically prove. You believe all kinds of things that you have in faith for. When it comes to the other side of any argument invoking anything they don't have physical accessibility to, suddenly it's just unacceptable and unthinkable and it's like unconscionable. It's like, no, you're just a hypocrite. And you're bad fit.
I am muted, by the way. That's really
Well, thanks.
rude.
I got to get all that off. That was cool.
No, I wasn't planning on it. You seem to be under the impression that memorizing a script means you're smart.
What? I just
It
made all that up. I
doesn't.
couldn't even repeat it.
Memorizing a script doesn't make you smart.
How's that a script? I just said a bunch of random stuff. I couldn't even
It's
repeat
a
it.
script that you repeat many times in many different forums.
I've probably repeated the rock turned into fish thing quite a few times,
Yeah,
but
yeah. Memorizing a script doesn't make you smart, Witsit.
Hey, do you believe in in consciousness?
I believe that consciousness is produced by brains.
But no, but it's produced by it.
It is a consequence of brain activity.
So you do believe in consciousness?
Yeah, it is a consequence of brain activity.
Okay, so then it's not synonymous with brain activity. Uh-oh. Dun dun dun. And then I'd say, do you believe in the mind? Well, I believe in the brain, but do you believe in the mind? Yeah, I believe in the mind. Are
Yeah,
they the same thing? Are they the
mental
same thing?
states, mental states are brain states. Yes.
Is the mind the same thing as the brain?
Not necessarily,
Oh, okay.
right? So you
Okay.
can say of me, for instance, that I believe that Donald Trump is president of the United States, and that proposition would be true of me, even if I was
True.
sleeping unconscious. That would be a true statement about my mental states.
You believe in
Even,
truth?
of course,
What? So there's like definitive truth?
I don't know what that is. Truth is just
Is there
truth,
absolute
right?
truth? So there's
Truth is
absolute
just.
truth.
I don't. That doesn't make any sense. Truth. If something is
How does it
true,
not
it's
make
just
any
true.
sense?
Yeah, because there doesn't add anything.
Well, yeah, it
True
does. There are different types of truth. There's subjective truth
is
and
it.
there's objective truth.
There's no such thing as subjective truth.
Yeah, there is.
No, there isn't.
So you do believe in consciousness?
Yeah, it is a consequence of brain activity.
Okay, so then it's not synonymous with brain activity. Uh-oh. Dun dun dun. And then I'd say, do you believe in the mind? Well, I believe in the brain, but do you believe in the mind? Yeah, I believe in the mind. Are they
Yeah,
the same thing? Are they the
mental
same thing?
states. Mental states are brain states. Yes.
Is the mind the same thing as the brain?
Not necessarily.
Oh, okay.
Right. So you
Okay.
can say of me, for instance, that I believe that Donald Trump is president of the United States, and that proposition would be true of me, even if I was
True.
sleeping unconscious. That would be a true statement about my mental states.
You believe in
Even,
truth?
of course,
What? So there's like definitive truth?
I don't know what that is. Truth is just
Is there
truth,
absolute
right?
truth? So there's
Truth is
absolute
just.
truth.
I don't. That doesn't make any sense. Truth. If something is
How does it
true,
not
it's
make
just
any
true.
sense?
Yeah, because there doesn't add anything.
Well, yeah, it
True
does. There are different types of truth. There's subjective
is
truth and
it.
there's objective truth.
There's no such thing as subjective truth.
Yeah, there is.
No, there isn't.
Someone can think it's subjectively true that chocolate ice cream is the best.
Yeah, that would be true, wouldn't it, of them, that they believe
Oh,
chocolate
of
ice cream is the
them?
best.
Just a
Yes.
different way of saying subjective.
No.
You definitely are not going to be able to hang with a transitional argument. Let's be real. Let's not even waste our time. Let's not even waste our time.
Yeah, you should run away.
Okay. What's the first law of thermodynamics?
I don't know.
Matter and energy cannot be created nor destroyed. What's the second law?
I don't know.
Entropy will always increase, amount of usable energy will decrease. Okay, so where did the universe come from?
I don't know.
What's the universe made of?
Stuff.
What kind of stuff?
Nobody knows. Nobody has a theory of everything for the universe.
What are the two main categories of stuff?
There
Matter.
there are fields.
Yes.
It's fields.
Matter and energy.
No, it's
In your paradigm,
fields.
field. Okay, define field.
So there are several different quantum fields that exist, and what we call matter are perturbations or excitations of the relevant fields.
Oh my God, bro, you're literally just using our terms now. Can you define field?
Yeah, it's a region that returns a value.
It's math.
No, it's a region that returns a value.
A value is math. A region is described by space,
Yeah,
dimension,
it's
which
an
is
area.
math.
It's an area or a region for which
So
it returns a value. Right.
returns a
So
value.
in the magnetic field, right? Points
Now stop giving me
in the
different
magnetic
types of
field.
fields.
Points in the field will return certain values, and it'd be different than that, say, in an electric field. There'd be different
Okay.
values returned.
Yeah, but you keep
The
giving me different
gravitational
types
field.
of fields.
Yeah.
I asked you to
Yeah.
define field, and you're like
I
quantum
told you what a
field.
field is. I told you
And
what
I
a
asked you
field
to,
is.
okay, a region that returns a value.
Yep.
So nonsense, like math. That's
I
just
don't
math.
know.
So the
What's
universe
wrong
is
with
made
that?
of
What's
math?
wrong?
Is that your
No.
universe is made of math?
No.
Okay,
don't
so
think
it's made of
so.
matter and energy.
No, it's made out of quantum fields. Matter and energy.
Quantum fields are just
does
matter and energy.
Energy doesn't really exist. Energy is just a bookkeeping notation.
Well, in physics, I agree that energy is not properly defined, actually, but we
Actually,
use
it's
it
well
to.
defined.
No, it's
Energy
not.
is the ability to do work. That's what
Oh,
energy
so
is.
now it is a real thing. Suddenly, now it is a real thing.
No, that's a bookkeeping notation. It's just the ability to do work.
Yeah, which doesn't tell us what it is.
Matter is just
Okay, this is this.
a perturbation of the relevant fields. An
Okay, so you're
excitation.
just a contrarian.
Let him finish.
No, this is just the standard model.
What? The standard model is the universe is made of matter and energy.
No, the standard model is that the universe consists of quantum fields. That's the standard model.
Quantum field or consist of energy.
No, I don't think so. No.
Well, you're wrong.
They can contain energy, but they are not themselves energy.
Fields in your paradigm are mathematical descriptions of energy. An electron field is the localized excitations of
That's what I
our
said.
electrons inside the field, which are energy, right? So it's a mathematical description and quantification method used to describe localized energy. Okay. And if you deny this, you deny relativity in and of itself. E equals mc squared is the entire
I just
proponent.
told you. You're just agreeing with me. You just said that electrons were excitations of a field. That's what I said. You're
No,
just
I didn't say of a
repeating what
field.
I said and claiming that it's for your own. I
I
said
didn't say
that,
of a
not
field.
you.
I
I
didn't say
said
of a
that.
field. First of all, you said excitations and perturbations, but I didn't say of a field.
Yes.
That I said in.
You said in?
Yeah, in a field. But the problem with that is you're invoking field as a real thing, but in modern like mainstream physics, right? They claim that it's math.
No. The quantum
Yes.
fields are real. They're physical. They permeate all of space and time.
Yeah, I know you like to hijack the ether, but claim it's not there. We get it, but like, what is okay?
There's
So
no ether. There's no
if I
ether.
take
Ether
okay,
was
sounds good.
falsified by the
Where's
Memphis
Gatebreaker
Memorial.
screaming and white knighting all of a sudden? It's funny how you only do that one way, huh, Gatebreaker? So if I take all the localized excitations out, what's left?
the vacuum state.
The vacuum state. So fields are vacuum state.
What you get is due to Heisenberg's uncertainty, all of the fields can never be completely at rest. So you get a bubbling region of virtual particles coming into and out of existence.
Virtual particles aren't real things. They're merely mathematical descriptors and placeholders. Hence the person that actually created the idea saying that they've never been the input or output of any experiment ever. Their existence is questionable at best. They're merely just used to balance equations. So anyway, if you like, we can't have the conversation if you can't even
I
just be
schooled
intellectually
you.
honest enough. No, you didn't.
I schooled
You
you.
can't.
I schooled you the other day.
No,
I
you
schooled you
didn't.
the other day on virtual particles.
No,
I showed
you
you
didn't.
a study, a paper, and a link to a popularizer, Sabine Hasselfelder, who talked about how virtual particles are real.
Your own source literally said that they were virtual and not actually detected. If assumed to be true, they thought that the effect that was caused was due to virtual particles, but they don't actually know. That's what your own
Well,
source said.
they do, and Sabine Hasselfelder backs up what I said about it.
I don't care what scientific communicators say to the dumbed down masses. So
Because
this is the
Sabine
thing. This is
is
the
a
thing.
physicist. She doesn't get things wrong when it comes to particle physics.
Okay, so if we take matter and energy out of the universe, you're claiming there's still stuff left?
When you take away everything, what you're left with are fields, right? That's what's left.
But
That's
fields
what
with
nothing
nothing in
is.
them.
That's right. That's what nothing is. Nothing is quantum fields.
Can
The
you cite that?
background vacuum state. That's
Wait,
what
can
the
you
vacuum
cite
state is.
can you
Yes.
cite where it says that fields can exist with no excitations?
That's what the field is. It exists, and the particles. So for instance, a photon is an excitation of the electromagnetic field.
Can you cite that
This is just a
fields
standard model. This is the
exist with
standard
no
model.
excitation? No, the standard model is that math is or fields are a mathematical description of the location of localized excitations.
Yeah, that's what I said.
No,
Congratulations,
no,
you
no,
come
no,
around
no,
to
no.
my. You're
That's not
just
what you said.
what this is a tactic that you use. You admit what I said and then claim that you win. But you are just agreeing with what I said. I said that particles are local excitations of the relevant field. You just said that and claimed that you somehow win. That is not winning, that's you losing.
That's not what I just said. I said that in standard model, fields are simply the mathematical description of the location of localized excitations. So, going to actually engage with what I'm saying, or we're just going to
That
move
was
on
just
to.
gibberish. The
Well,
location of
hold on a
Okay.
localized
second.
locations.
Hold on, Brenda.
It's
All right,
just
hold on.
gibberish.
All right, ZZ Top, you're actually hot micing, but did you want to join in on the convo?
Oh,
Well,
sorry.
I think Witsit
Just hold on, Brenda.
I think
All right.
Witsit wants to move on. I think he
Yeah.
wants to move on.
I think everyone does. Just chill for a sec. ZZ Pop, are you there? Because he.
Yeah. Hey, I just came a second ago. Sorry for hot micing.
Are you all right? I just didn't know if you were trying to get in, or maybe you could pick if you were
talking about quantum fields and such.
Yeah. I mean, Brenda's saying that that fields are a real thing. When I asked Brenda to define what a field is, she said a region that creates a value.
Yeah, I mean, like temperature is a field in the sense of like at every point you can put a thermometer and register the temperature, so you get a temperature value at each place in space.
Right? Would you agree? Temperature is energy.
Thank you.
Yeah, a type of thermal energy. Yeah.
Right. So if we removed all the matter and energy in the universe, would fields still exist?
I mean, you could say that the temperature field is then just zero everywhere. You could still give it a value. It would just be very boring.
But is it
CC
just
Top,
math, or is it an actual thing?
CC Top, does Heisenberg's uncertainty principle say that a field can be exactly zero?
It could be.
No,
Now we're
it
getting into
can't.
the uncertainty principle, in which that uncertainty principle is if you know one type of variable highly well, you don't know a different variable.
Right. So it can't be zero. Right.
It would be, yeah, impractical to
Correct. Correct.
narrow a variable all the way down to exact
Yeah.
precision. There's
Correct.
some range of uncertainty around whatever
Yes. Thank
value
you.
you think it's near what the average value is.
The
Thank
universe
you.
is made of matter and energy, and everyone knows this is true. And any worldview that requires me to do the mental gymnastics required to dispute that is logically bankrupt and can be dismissed.
Aren't you pro ether?
Yeah,
Etheric
yeah.
frameworks.
hmm
Isn't that very
I am.
similar to what the description of the field is? Like something that
It
exists
is
at all
similar,
places in
yeah.
space?
Yes, but it's an
No, there is.
actual physical. It's an actual medium with physical properties that permeates all of space. And if
Oh
I
my
were to take
God,
all
yes.
the matter and energy away, like there'd be an actual physical medium there that's outside of the material universe, right? So it's not the same. It's just like arbitrarily claiming fields.
Yeah, so like the limit to the example of temperature as a field is that is just a description of the average amount of thermal energy at a point in space. And then we say, oh, it's molecules vibrating. And then the interesting question is about fundamental fields that aren't made of anything else other than themselves. Like whatever value they take at every point in space, like that is as fundamental of a description of what's happening at that point in space as you could possibly get. And that to me seems very similar to how people describe the ether as being the fundamental substance that permeates all of space.
Yeah, the only difference
Correct.
is, right, like it depends on what conception that you invoke. Like if you look at Tesla, he referred to the ether as an actual medium with a tenuity beyond conception, whether you believe it's like actually like some material medium that's extremely tenuous or something that's outside of the material world that's effectively like a background. It's still like a real physical medium, as opposed to like the relativistic application where Einstein says that it's not akin to any ponderable media, but then still just like attributes physical properties to concepts or whatever. Like a long story short, like yeah, I'm a proponent of the ether, and I think the ether is basically the metaphysical background. And then when excited, it manifests in the physical world as real physical phenomena that we call matter or energy. So when we talk about like the physical universe, we would classify it in different categories of matter and energy. And then the initial primal inertial state would be the primary substance or the ether that permeates all of space. You know what I mean? And when it's excited, that's when we're able to see it.
Yeah.
Yeah.
I guess other than using the word actual physicality and the kind of philosophical implications that that has, I'm not sure exactly where the disagreement is within this conversation about what reality is made of. But I only came in like a
Oh,
minute ago, so I
yeah.
missed the
Well, I would
beginning.
agree with that. I would agree. Like physical, like defined as like a real physical interaction or an interaction in the physical world. And like, yeah, I would agree. Like, I think the better way to describe it probably is actual.
Mhm.
But no, the disagreement is just that I was about to walk Brenda through the logical requirement of creation, and I don't know. She denied that the universe is made of matter and energy, so I don't really know what to do with that. Like, I think we all know that it's made of matter and energy, you know? I mean, that's why all of our laws of physics govern those two things.
Brenda, is that the case? That you were saying the universe is made of something else that isn't matter and energy?
How did Brenda leave? Oh, no.
Yeah.
Oh, yeah, yeah, yep. Brandon.
It's all good. Yeah. I mean, because this is the thing that I get really frustrated with like the mainstream is they invoke fields and they talk about them like they're real, but like when you press them for a definition, they just invoke math.
Yeah. Yeah, that
Yeah.
is frustrating. There's a conceptual gap at the center of physics of a hesitancy for people to kind of take any sort of clear stance on what these things are. A kind of agnosticism of just saying like, oh well, it's equations that output results. Shut up and calculate. Don't overly press the point of if these things are real or not. I've never even really understood it of someone saying that a model they're like, oh well, it describes physical reality, but it's just a model. It's not real. It's like honestly, that's always kind of been very incoherent to me. Because I don't know what we do in science other than creating models, and we hope that they're getting closer and closer to a picture of reality. So to say on one hand, like trust the model, and then to also say, well, it's just math, it's not real, has never felt coherent to me. Kind of trying to have it both ways. So I think that a lot of physicists are trying to avoid having to actually make any sort of ontological commitments on their part about what they are saying is actually real.
That's what it is. That's what it is. Which is lame. So like,
It's like
yeah,
why?
yeah.
Why get into physics if you don't want to, uh, you know, take a side in what reality is? I mean, even if you're wrong, at least took a stand on a particular position. It's not so bad to be wrong. That's better to take some position and be wrong in my mind than to kind of use wordplay to try to avoid ever making any sort of philosophical commitment to what reality is.
I just
Do
think the
we know that?
implications are uncomfortable for them. Good.
Do we know that the celestial is matter and energy, though?
The
Well,
celestial.
Like what's in these stars and the planets and the sun? Do we know that that's matter?
or
I assume
energy.
it is.
I
I
mean,
can't
we
say
would
I've
have
ever
to
touched
just
the
use special
star.
pleading.
I can't say I've ever touched the star, but I would assume it's made of matter.
It would require special pleading, right? Like invoking the exception to a universally accepted principle. So, like, yeah, we can't go there, but there's really no reason to think that it wouldn't be energy, at the least.
I mean,
Maybe energy, but I don't know about matter though.
But that's fine.
It might be a completely different realm.
Well, if it's a different realm, then it wouldn't really be the physical universe that we were talking about.
Right. That's all I had.
So obviously, I do think it is like a different realm, but like, I think energy is there. But like, yeah. I mean, either way, the real reason that Brenda denied that, it was obvious because Brenda's familiar with my argument, I would assume, where you go through like matter and energy cannot be created nor destroyed. So if we ask how did the universe get here if it's made of matter and energy, like, well, it couldn't have been created, so it had to always be here. So then we go to the second law where entropy increases and the amount of usable energy in the universe decreases over time. And for it to decrease, it has to decrease from a beginning point. If it has a beginning, now we go back to our first question, right? Like, oh, it couldn't have always been here if it has a beginning because that's a contradiction. And so now we have to violate the first law to get the matter and energy to be here. So necessary antecedent to the creation of matter and energy is a creator. And you literally need something that violates natural law because the first law of thermodynamics is natural law. So anything attributed to a force not limited to the laws of nature is by definition supernatural beyond nature. So like you need a supernatural creator to create the matter and energy to have the universe. Right. And it actually has to be external to the universe. It has to be eternal since it isn't limited to the time, like let's just say concept that we have of the physical universe, or even say restraint. So you like have an external supernatural or external eternal supernatural creator, like literally, right? Because like matter and energy cannot be created.
nor destroyed. So if it is created, then the NCN's creator. So yeah, people don't like that argument. And by the way, you could acknowledge that in terms of like the physical requirement, and then not invoke any religion, any deity, any personification, any anything like that, any malevolence or benevolence or anything like that. But that's that's the only reason you're going to hear somebody randomly say that the universe is not made of matter and energy. Because if you really boil that conversation down, there is no way out of it. You can try to say, oh, well, maybe there's multiverses, and then you can invoke like something like the crunch theory, but then you violate the second law again. So you're kind of stuck, there's really, whatever it is, we have to have something that was like a primary mover. And of course, I'm not gonna rant and rant, but like the Big Bang theory has this problem anyway, right? Like you have the singularity, but where's the pre-existing energy, right? I mean, you have the problem regardless.
I mean, our understanding of conservation of energy might not be an absolute law. Like, I mean, we don't know for sure where the universe's origin is, but I think we could imagine saying like, okay, like on the time scale of a human life, it seems like energy is conserved, but this is a approximation. There's some deeper principles involved that do allow for processes that generate energy that don't conserve it in the way we're familiar with. I don't think that this gets around the idea of like the prime mover, sort of the question of sort of the initiator of existence. This is sort of a smaller point of being like we could start loosening up and wondering if things that seem to be conserved laws in our universe today necessarily have to be.
Well, I would say if the second law is wrong, like it's gonna shatter physics, right? I mean, it's kind of like the most like bulletproof natural law, maybe, right? I mean, this is actually like the one thing that even Stephen Hawking had to concede to, where he talked talks about the beginning of time, and he's like, yeah, I mean, there was a historical debate throughout like many years about whether or not the universe had a beginning, and then typically that was just on philosophical grounds, but that was prior to our discoveries in the 20th century, and based on what we know now and our understanding of the second law now, we now know there had to be a beginning because the amount of usable energy is decreasing, right? And so, and then the way he put it was similar to the argument about human progression. In order for humans to progress, they had to have a beginning point to progress from. And then he cited Arthur Eddington, who said, it's no big deal if your theory doesn't match observation because our observations are wrong all the time. You may be right after all. Just time will tell. But if your theory is in conflict with the second law of thermodynamics, it has no future but to collapse into the deepest humiliation. I mean, I kind of have a tendency to agree with that, right? Like I feel like if I put the second law into really simple terms, and this is just my opinion, some people don't like this characterization, but it's just that all systems seek equilibrium, and the process of seeking equilibrium uses usable energy.
Yeah,
So you can never stop that,
the second law in some form does seem more fundamental than almost anything else because it applies not even just to the rules of physics, but to much more abstract concepts like information. It's like the second law almost seems to be kind of a tautology, that systems are most likely to progress towards their most likely states. Those most likely states being, equilibrium states. Like it's a bit of a cyclic thing when you dig into the definition of it. So yeah, sure. So we need some sort of initiation principle, first mover, an explanation of why the universe exists, why it's initialized out of equilibrium and then gets to progress towards equilibrium. I mean, it sounds like you're angling for maybe some sort of personified, creator type figure.
Yeah, I mean that's my interpretation of it, right? Like, but that I don't think that argument proves that though. Like, I only invoke that argument. I mean, I think it can be drawn out to do that, maybe, but like that argument, I do use the words very specifically though, right? Like, if mathematical energy was created, then like the antecedent of that is a creator. You know what I mean? And so, yeah, I mean, normally we call that God, but like there's a distinction there in a way, right? Because like God kind of personifies a deity in modern usage, yeah. So like technically it's just creator, like it created the matter and energy. It's a mechanism at that point. It's a causal agent. And then supernatural just simply meaning it's beyond like our current scientific understanding and the laws of nature as we know them to exist, right? So I mean, like it's like a technical definition of supernatural using the etymology of supernatural. But I mean, yeah, for all intents and purposes, that's how we define it. That's how we define supernatural, So yeah, like a supernatural creator. I think that the personification part of it is going to get into more of a transcendental argument and how can you reason? How can you know? What's the foundational premise for knowledge itself? Stuff like that, right? I mean, you could obviously invoke like the sequential information observed in the universe, and that requiring intelligent agency, you get information and intelligence and da 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 da. But all these arguments are like technically separate arguments. Yeah. Which I mean, I love to talk about it, obviously. Yeah. Because I think okay, so like one of my favorite quotes ever is, and I'm probably butcher it, but the first gulp of natural sciences will have you an atheist, but at the bottom of the glass, God is waiting. Yeah.
I've definitely been very influenced by Plato's concept of the realm of the forms, the idea of like mathematical concepts and structures as transcendently existing outside of our physical world. Like we've got, the idea of a triangular object we see in reality. There's a concept of it in our heads. Some people would say it's a concept we've come up with, but then there's this idea of like, no, like um, the truth of these forms, these structures, something like the triangle, just to take the simplest example, but we could go way more complicated than that. Sort of exist outside of or exist before or beyond the specifics of our individual physical universe. There's kind of this higher realm of eternal truths, like ordered, structured truths that predates physical existence. And yeah, I've always found that to be a really interesting concept.
Yeah, like beauty, goodness,
symmetry. Yeah, maybe morality. You find it in that realm as well.
Yeah, and I'm not gonna lie. Like I like you too much to press you on the transcendental argument. Like that's how I think it's like that lethal, right? But like I do think, yeah, I just think that the transcendental argument's inescapable. I know that this room gets really frustrated with it because like, there's a group of people that like love love to bring it up. Because basically, if the transcendental argument is correct, then um, without acknowledging it, then you can't even make any claims. You can't reason. You can't stake any foundation for reasoning. Da 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 da. But it is very interesting that, like, when logically drawn out, the fact that we're able to reason itself is a proof of God, as far as I can tell, right? But then, what else is interesting, right? Is like just the very basic questions, like, um, what is consciousness,
or like, does consciousness exist? What is it? Where does it exist? How does it exist?
Yeah, there's a number of things I think you can't derive from a materialistic worldview. Like so, right? So some of these are the idea of like the realm of forms of mathematical, logical. I'd also say moral structures. Sort of eternal truths that exist outside of they're not contingent on the details of our physical reality that would be true if there was no physical reality, that would be true across all physical realities, things like that. And then another thing I think that you can't get to from materialism is the hard problem of consciousness, that like sure you could explain the functionality of the brain, of the neurons, of how you respond to hot and cold, but you can't explain the subjective qualia of what hot and cold feel like to the person who's actually experiencing them. I think that also belongs to sort of the realm of metaphysics, and it's draw a bit of a distinction between cognition and subjectivity. Like I think that we can explain how the brain processes information physically, but I don't think that you can explain where subjective experience comes from
Like the experiential
materially.
component.
Yeah, and I
Yeah.
press people on it because I'm just like, like I'm sure, I'll ask people. I was like, how do you know that other people aren't philosophical zombies? How do you know that other people are actually feeling the things that they're feeling? And most people are, quite confident in extending this to humans and animals. And then I keep pressing them. I'm like, what about insects? What about plants? What about amoeba? Like where do you draw the line where you start saying, oh, I think that thing is just automatically responding to its environment? But no, it doesn't. The amoeba gets punctured by something and it goes through all of these different responses to try to protect itself. But those are just automatic responses. It doesn't feel pain. I'm like, how do you know? And it's very interesting to find where people draw the line on the question of sort of what they're willing to imagine is having some form of subjectivity. And yeah, no, I think that this is not a physically answerable thing. Like this does belong to the domain of metaphysics. And it's interesting because people will tell me that my kind of very clear statement here of the importance of metaphysics, of the fact that there's many layers to how we experience reality, logic, subjectivity, morality, things like that, that I don't think you could ever derive from a purely materialistic worldview. And people will say like, oh, well, that's God, or that's what we call God, or whatever. And I'm like, okay, sure, that's fine, but that doesn't sell me on other theistic beliefs that you might have. I'm, like I like the, if you want to go further into saying, and God, the eternal truths, the transcendent truths, the initiator that pre-existed our physical reality, and this God is sending these specific messages, then I'm going to be like, all right. I'm not necessarily getting on board with that yet without, compelling reason to believe those claims. So, that's why I'm hesitant to call any belief in transcendent truth the same thing as belief in God, just because for most people, I think the word God does have these very strong associations with the personified God, like the Father in the Kingdom of Heaven image, um, which is a kind of very specific theological belief structure. Um, so, I don't know. I don't really care too much about how people interpret or categorize my position on this.
Yeah, I would say you're a creationist. Like, have you ever heard of the Lam cosmological argument?
Yeah, the Kalam cosmological argument.
Yeah, like
Uh,
whatever begins to exist has a cause. The universe began to exist, therefore the universe has a cause.
sure,
Yeah, that's
but
like
that's
a
not what
classic.
Yeah, but like people don't really want to end it there. They want to then bridge from saying that there's some cause that transcends time and space. They want to get from that to their specific ideas about what God
Sure.
is.
Sure, but like I think this is natural, right? Because if there's a God, like, or just say if there's a supernatural creator, if there's a creative force, whatever, like you're gonna have we have a natural inclination to want to know what that is, right? Like, and then like, so I mean, what is pretty interesting is that so one of the arguments that people have is that um only a God that has mm, like um personhood can be a sufficient primary causal agent because the experiential component of like say having a relationship like there's like a relational argument, right, where like well like if basically all that is good and just and right comes from the primary source, then the primary source must possess all of those qualities innately. That word used loosely, obviously. And then it's like, okay, well, how can a God um, have like innately have um, a relational component? And then like a Christian would say like, well, you have the Father and you have the Son and you have the Spirit, and that way you have relationality, and then you have choice, and then you have free will, right, or whatever. Which I am not doing that justice just because it's like kind of like a extensive argument, but it is actually pretty persuasive in my opinion. And then the counter would be like, okay, well, like obviously you can invoke some type of God with relationality that isn't exclusive to like the Christian God. And then they would kind of say, well, the same thing by a different name is still just the same thing. You say, okay, whatever. But yeah, I mean like what I would always encourage everyone though, like just in general, right? Like um you definitely whatever the truth is, and maybe I'm wrong about everything I think, right? But we definitely should keep trying to figure it out, right? Like because it's probably the most important thing ever, right? Or at the least we could say that it possesses quote unquote like the ability to be the most important thing ever, right? Like it possibly is has the potentiality of like what that answer is, the true correct answer being extremely important. You know what I mean? Obviously, there's the possibility that really isn't that important, that it's inconsequential, or that you have 4,200 religions and it's just man's primitive attempt to explain the inexplicable. That's the exact quote I said all the way up to like 25. That like religion is just man's primitive attempt to explain the inexplicable. Um, but like that's obviously a possibility, right? That there's this it's like a creative force and throughout all time man's kind of tried to find different ways to explain this, and then people have developed different religions and typically used and abused them for control over other people and manipulation and whatever it is.